Today, our lesson is about applications of graph. So first four applications that we want to discuss are the following: shortest path problem, critical path problem, the Chinese postman problem, and the traveling salesman problem. If you remember during the class introduction, I already discussed a few note about these applications, but for this session, what we're going to do is we're going to apply certain algorithms on how we get the shortest distance, the critical path, the Chinese postman trail, and the trail for a traveling salesman. So, gagamit na tayo ng mga algorithm for us to determine or to solve itong mga applications na to in graph theory. Yan. Okay? First, let's discuss about the shortest path problem. So, recall natin yung shortest path problem. So, let's say we have a graph representing a certain scenario. So, here, yung letter A to F natin refers to towns. Tapos, these towns are connected by roads. So, an edge represent a road that connects, let's say, the town A and town B that's connected by a road. And then the markings are the width or the length of the road. So, in our example, yung A to B natin is connected by a road 2. So, as I've always said, yung length doon sa graph, not necessarily proportional doon sa real life scenario. So, hindi naman necessary na ganyan talaga kahaba. So, minsan, syempre, nire-represent lang natin yung mga segments or edges as straight path. Pero in real life, hindi naman talaga straight yung mga road, di ba? So, yung topographical na itsura ng graph, not necessarily translated in a real life situation. So, basta ang mahalaga lang, there's a road between these towns. And the length of the road connecting these towns are represented by the weights. Okay? So, here, again, ang mga markings or ang mga weight natin ay length ng road. But of course, hindi naman kailangang length lang ng road. So, pwede rin naman na iba yung weight. So, later we'll include other kinds of weight. But the question here is, what is the length of a shortest path from A to L? So, gusto nating malaman, dalawa actually yung gusto nating malaman. If there, what path should we take that will give the shortest length of roads? And of course, ano yung length na yon? Pero it will already follow pag alam mo yung shortest path to compute the shortest length, syempre. Now, ang ginamit natin dito is shortest path. So meaning, yung shortest path not necessarily unique. Pwede naman na marami kang path of the same length, di ba? So, kaya shortest path. Hindi the shortest path. So, not necessarily na isa lang yung shortest path. Pwedeng marami. Well, of course, yung length, the length of the shortest path, isa lang yun. Kasi yung shortest, the length of those paths, pwede namang magsising haba sila. Yan. Okay. So, again, yung ating weight, hindi naman kailangan na length lang. So, minsan, syempre, pwede natin i-consider yung ibang uri ng weight. Pwede yung time taken to travel. So, gaano katagal i-travel from town A to town B. Yan. So, pwedeng in terms of time yung ating weight. Pwede rin in terms of cost of traveling the paths. For example, yung kung you're driving your own car, magkano gagastusin mo? Or if you're flying a jeepney route or an MRT route, so depende dun sa gagamitin mong form of transportation. So it will give you different cost of traveling from one town to another or from one point to another. So those are the possible weight that we can have dun sa graph. So pag ang weight mo ay time, of course, ang tanong mo, what is the quickest route? Ibig sabihin, the shortest possible time. Pag ang tanong mo, pag ang weight mo ay cost, of course, ang tanong mo, what is the cheapest route? So, ganun lang. So, all in all, pag sinabi natin shortest path problem, it doesn't necessarily mean na shortest distance. So, depende kung ano yung weight. So, kung ang weight ay distance, shortest distance. Kung ang weight ay time, shortest time. Kung ang weight ay cost, shortest cost or cheapest cost. Okay. So, these are examples of different path from A to L. So, pwede nating i-trace. Let's say from A to E. And then from there, pupunta tayo sa H. And then from H, pupunta tayo sa L. So, that's a path consisting of 3 edges. So, since the edges are marked as 9, 2, and 9 respectively, so a path length will be of that path is 9 plus 2 plus 9. So, here you can see that a path traversing from A to E, then to H, and then to L gives you a path length of 20. On the other hand, you can also take the path A to B, right? Then B to D, and then D to G, and then G to J, and then J to L. So the path length will be the sum of the weights of each edge. So that's 3 plus 2 plus 3 plus 5 plus 5. So that gives us 18. So although it consists of more edges, in that particular route, gumamit tayo ng 1, 2, 3, 4, 5 edges. Pero all in all, ang naging total distance lang natin or yung weight, 18. So it doesn't mean na mas konti yung number of edges, ibig sabihin na mas shorter yung path. Yan. So again, nagmamatter yung weight ng path. Okay? So in this two example, we see na yung path consisting of A to B, B to D, D to G, G to J, and then J to L gives you a shorter distance than the path on number 1. So the idea is, anong path yung gagamitin natin to get the shortest path or to get the shortest distance? So there are probably many approach that you can take para sagutin yung tanong na yun. Okay, yung to simplify things, kung ang edge ng bawat isa ay 1 lang. Okay? So we does not take in consideration yung pinaka weight niya. Ang gusto lang natin, number of edges. Of course, ang kukunin mo lang is the route with the least number of edges. So, pag nilagyan mo ng weight, doon na nagbabago-bago yung scenario. Pag walang weight, kasi madali lang namang hanapin yung shortest path. That is just the path with the least number of edges involved in that path. But in real life, syempre, hindi naman ganun yung nangyayari. So, isa pang pwede natin gawin, let's make a model. So, ang gagawin mo, magmo-model ka ng map by knotting together pieces of strings. So, usually, if you're trying to explain graph theory sa, for example, elementary and high school, this is one way to do it. Ang gagawin mo, guguha ka ng mga string, okay? So, for example, yan yung pinaka-map natin. Kukuha ka ng string, ilalapat mo siya dun sa map. Kung yung map mo ay scale representation or proportional representation. So, halimbawa from A to B, diba? From A to B, kukuha ka ng string. Tapos sa ruler, babakatin mo yung 2 cm, for example, kung ano yung weight. Tapos, maggagawa ka ng knot on 2 cm. And then, from 2 cm, so for example, dapat dalawa yung string mo para ma-divide mo yung isa. Gagawin mo 2, inanot mo dun sa after 2 cm. Yan. Tapos yung isa, kukunin mo yung length na 4 cm, tapos inanot mo ulit. So, kumbaga, yung mga knot will be representing your town. Tapos yung length nung string from knot to knot, that will be the length of the road. Yeah. So, you now have a string representation nung graph natin. Okay. So, ang gagawin mo, para malaman mo yung shortest path, kukunin mo yung point A tsaka yung point representing L, yung nagre-represent doon. Tapos hatakin mo lang yung string. So, more or less, makakakita ka ng string. Habang hinahatak mo kasi yung string, di ba? Hahatakin mo from this side and then from this end, dito na lang, from that end. So imagine mga string yan. So yung iba dyan mahaba, yung iba maigsi. Oras na ba natin mo from A to L? Yung shortest length, yun yung pinaka-tight na part ng string. Yung iba magiging mas loose. Parang pag nakakita kayo ng duyan, nakakita na kayo ng duyan na gawa sa string. And I hope you can imagine yung mga duyan na gawa sa string. Ayan. Diba? Parang ganun lang yung idea. Pag hinatak mo yung dalawang nut, kuha ka ng dalawang nut, pag hinatak mo yun yung shortest path. So you can try that at home during your free time to test the idea. But that's a very simple technique and it will give you the correct answer for as long as, syempre, tama yung at least proportional yung mga length ng string na gagamitin natin, di ba? So it's one way to imagine the shortest path. Syempre, kung masyadong mahaba yung ibang path, magiging loose yun pagka in-straighten mo na yung pinaka-string natin. Yan. And the good thing about that representation, kahit anong dalawang string ang gamitin mo, halimbawa itong string na itong A at saka itong G, pag binanat mo yung string, yung shortest path yung makukuha mo. Tapos magiging loose. For example, baba natin ito yung shortest path, di ba? So magiging loose yung ibang part. So anything na tight, yun na yung shortest path mo. Yan. Ang kailangan mo lang gawin, i-mark mo properly yung mga string para madali mong ma-determine. Okay? So again, it's a very good experiment to visualize the shortest path. Yeah. But of course, since we are mathematical student, gusto natin mathematical yung approach, di ba? Okay. So another possible thing to do is to list all possible routes. So if you're a student of statistics and probability, medyo you're fond of getting all the possible scenario. So that's okay. So gagawin mo lang, especially if this is just a small graph, ililist mo lang lahat ng routes. Okay? Then get the length of each path. So by listing, kunin mo yung pinaka maliit na value ng path or ng length, then that's it. Yun na yung pinaka shortest mo. Okay? Now, ang problema sa ganitong approach, syempre, pag mas marami na yung graph mo, mas marami yung listahan mong gagawin. Diba? Sobrang dami ng possible scenario na gagawin mo. For example, in this case nga lang, diba? So, from A, you have a choice to go to B or to C or to E. So, meron ka ng 3 scenario mula sa A. Pero from B, pwede kang pumunta sa D tsaka sa E. So, times 2 na. From C, pwede kang pumunta sa E tsaka sa F. So, times 2 na ulit. From D, pwede kang pumunta sa G. Isa lang yung case. So, times 1. From E, pwede kang pumunta ng G, H. So, times 2 ulit. So, yung mga possible scenario, habang dumadami yung vertices mo, habang lumalaki yung graph mo, dumadami din yung mga possible route. Yung route na sinabi ko kanina, yun lang yung from left to right. Pero pwede naman na from B, pupunta ka ng E, babalik yung E sa C. Pwede rin yun, walang problema. That's still a route. Tsaka ka palang pupunta ng F. So again, yung paglilista ng mga lahat ng possible scenario, medyo dumadami na. Pagka ang method na gagawin mo ay listing. Yan. So now, graph theory offers a different method on how to do that. So what we can do is we can use different algorithms on how to find the shortest path. So this is one algorithm. Okay? Ang gagawin natin, so explain ko muna yung step, then later summarize natin para mas madaling maintindihan. So we start by assigning a label on our starting point. So ang gagawin natin, yung label natin ay yung distance na na-travel na natin from one town to the next. Para ang gagawin natin, titingnan natin yung possible scenario ng pagpunta from one town to the next, from left to right, hanggang makarating tayo sa final destination. And then, according dun sa label natin, titingnan natin kung ano yung pinakamaliit na value na makukuha natin. Yan. So, then, as we go from left to right, tinitingnan natin lahat ng possible scenario until makuha na natin or ma-reach na natin yung pinaka maliit na value. Okay, so let's do this. Let's do this. So again, ang gagawin natin, ito yung unang step. From your starting point, lalabelan mo siya ng 0 since wala ka pa namang kahit ano. Particular scenario, ang what you call this, ang starting point natin ay A. So mag-start tayo dito sa A. Tapos lalabelan mo na siya ng 0. So, i-fix mo na yung label niya. Kasi wala ka namang ibang starting point kundi A lang. So, yun yung given. So, we label A as 0. And then from there, we proceed kung saan yung mga possible path na pwede nating daanan. So, ang mga naka-adjacent lang naman sa A ay B, E, tsaka C. So, lalagyan natin ng temporary label yung mga vertices na yon. So, paano natin lalabelan? Ang magiging label nun ay label nung preceding vertex plus yung distance na kakailanganin para marating yung vertex na lalabelan natin from the preceding vertex. So, in this case, label ng A plus yung weight ng edge AB. Okay? So, ang magiging temporary label, temporary lang kasi pwede pa magbago yan. Ang magiging temporary label ng B ay mula kay A papunta kay B, 3. So, that's 0 plus 3. So, ang temporary label ni B, 3. Okay. Ang temporary label naman ni E ay label ni A kasi doon siya kay A manggagaling plus yung weight papunta kay E, mula kay A. So, ito yun. So, 0 plus 9. Okay. Next. Ang label ni C ay ang label ni A plus yung weight papunta kay C mula kay A. So, mula kay A, pupunta ka, so plus 2. So, 0 plus 2. 0 plus 2. Yan. Nilalagay ko yung 0 para makita natin yung pattern later. So, label nung pinanggalingan plus weight papunta sa pupuntahan. Okay? So, that gives us 2. So, that's the first step. So, ang temporary label nito ay 3. Ang temporary label ng E ay 9. Ang temporary label ng C ay 2. Now, if you're deciding kung ano yung shorter path, syempre, ang tendency mo, pumunta dun sa shorter distance. Tama? So, ang gagawin mo, kukunin mo yung pinakamaliit na value doon sa mga nilabelan natin. So, in this case, ang pinakamaliit na value is yung C. Tama? Ibig sabihin, pupunta ka doon. Yun yung susunod mong pupuntahan. Kasi yun yung pinakamaliit na value eh. Yan. So, proceed to vertex with smallest temporary label and permanently label it. Ibig sabihin, the shortest possible distance from A to C is already 2. Kasi siya na yung pinakamaliit sa 3, sa 9, tsaka sa 2. So, permanently, ile-label mo na siya. So, magiging label na ni C ay 2. So, bibilugan ko na para lang ma-mark ko na yun yung permanent label niya. So, lalagyan ko ng subscript na A para meron akong idea na yung C nanggaling ako kay A. O kaya, pwede mong lagyan ng mark na arrow para alam mo na para makarating ka the shortest possible way kay C, dumaan ka galing kay A. Kasi pwedeng namang dito ka dadaan papunta kay C. Pwede yun. Pwedeng ikot ka muna ng malayo doon. Pwede naman. Pero since yung shortest possible distance na ay galing kay A, le-label na natin siya permanently. Okay? So that's the idea of the label. Siya na yung shortest possible way papunta doon sa nilabelan mo na yan. Yan. Okay, now, mula doon, ang goal kasi natin mula kay C makarating kay L. Mula kay A makarating kay L. So, ang gagawin mo, you give again vertices adjacent doon sa current position natin, which is C. So, ang mga adjacent sa current position natin, yung E tsaka yung F. So, ang gagawin mo, lalabelan mo yung E tsaka yung F as if galing ka kay C. So, this time, si C na yung point of reference natin. Okay. So, give vertices adjacent to it, doon sa C. Pero temporary lang muna. So, si E, para makarating ka kay E mula kay C, kailangan mo label ni C plus weight papunta kay C, wala kay E. papunta kay E mula kay C. Alright. So that will be 2 plus 6. So that's 8. So now we know na mas maigsi yung dumaan kay C kesa manggaling kay A, papunta kay E. Since pag galing ka kay A, 9 yung label mo, pero pag galing ka kay C, 8 lang yung label mo. So again, this is 2 plus 6, which gives us 8. Since mas maliit yung 8 sa 9, papalitan mo to ng 8. Ibig sabihin, it's a better route to go from C to E than to go directly to E from A. So, yun yung nangyari. So, kaya pinalitan na natin. So, that's why ang concept natin kanina, temporary label lang. Kasi pwedeng may mas maigsing path papapunta doon hanggat di natin nakikita ng lahat ng possible scenario. Okay. So, ang temporary label ngayon ni E ay 8. So, i-disregard na natin yung kaninang temporary label niya na 9. Now, ano naman yung temporary label ni F? So, label ni C plus weight papunta kay F galing kay C. So, that's 2 plus 9. So, that's 11. So, that's the temporary weight ni F. So, titingnan mo ngayon yung na-labelan mo na. Okay? Tapos, this time, magpuproceed ka dun sa pinakamaliit na value ulit. Okay? Now, pag tinignan natin yung value na meron tayong 3, meron tayong 8, meron tayong 11. So, this is 3, 8, 11. So, that means, ang pinakamaliit ay B. So, yung label ni B, fix na sa 3. Ang ibig sabihin nun, siya na yung shortest path mula kay A papunta kay B. Basta na-fix mo na yung label. Kasi after 2 iterations, wala nang mas maliit pang way papunta kay B, kundi yung kaninang path. Okay? So again, the idea is to get the list label, tapos doon ka mag-start ulit ng iteration. So now, what we're going to do is to proceed to vertex with smallest temporary label. Again, at this time, ang smallest temporary label natin ay yung B, which is 3. So let me go back here. Yan. So if i-fix ko na to, sasabihin ko galing ako kay A, and then I'll repeat the algorithm mula kay B. So again, ano yung algorithm? Mula kay B, pupunta ka sa lahat ng, so dito ipipix na natin, L of B is 3. Pupunta ka sa lahat ng possible vertices na pwede mong puntahan mula kay B. Pero hindi ka na babalik kay A. Okay? Lahat lang ng pa-forward, from left to right. Yung hindi mo pa napuntahan, yung hindi pa na-fix yung label. Yan. So, ano ba mga pwede mong puntahan mula kay B? Yan. So, ito, finix na natin to. Yan. So, ang pwede ko pang puntahan ay yung D tsaka yung E. Tama? Yan ang pwede kong puntahan. So, ang rule, para makuha mo yung temporary label ni D tsaka ni E, mula kay B, i-add mo yung weight. Yan. So, ang weight ni B ay 3 plus papunta kay D, ito pa yung isang map na lang para mas madali. Papunta kay D, that's plus 2, so that's 5. Papunta kay E, so that's 3 plus 4, which is 7. Currently, ang label ni E ay 8. Pero nakita natin na mas maliit yung 7. So, papalitan na natin yung temporary label na 8. Gagawin na natin 7. Ibig sabihin nun, mas maigsi yung dumaan ka from A to B and then to E kesa dun sa kaninang path na A to E or AC to E. So, yun. Alam na natin na habang nai-improve yung path, papalitan lang natin yung temporary label. So, this is already fixed. So, now, the labels are 5, 7, and 11. So, I guess nakukuha nyo na yung pattern. Kukunin mo yung pinakamaliit na temporary label, siya na yung magiging fixed label, and then from there, magpuproceed ka sa lahat ng possible adjacent vertices. to get the next temporary label. Yan. Kung yung nakukuha mong temporary label ay mas mataas kesa dun sa existing temporary label niya, hindi mo papalitan. Siyempre, ang kukunin mo lagi yung smallest. So, ang idea is smallest path. So, ang rule, get the smallest. Yan. Okay? So, now what you do now is to proceed with the smallest temporary label and permanently label it. So, kung titingnan natin again, ang mga labels existing ay 5, 7, 11. So, ang pinakamaliit ay yung 5. So, you fix that. So, label ni D ay 5. So, mafi-fix na ito. Yung label na 5. And then, update the temporary label of vertices adjacent to D. So, ang tanging adjacent lang kay D na hindi pa nalalabelan, so hindi na tayo babalik kay B. So, ang hindi pa nalalabelan ay G. So, paano labelan ang G? So, label ni D na 5 plus yung weight papunta kay G. So, that's equal to 3. So, that gives us 8. Okay? So, ganun ulit. Pag na-labelan mo yan ng 8, titingnan mo ulit kung ano yung mga smallest existing label. And then, start from there. Yan. So, gawin natin yan ng sunod-sunod. So, for example, balik tayo dito sa 3. So, from 3, kukunin mo yung papunta kay D tsaka kay E. So, that gives us 5 and 7. Yung F na labelan na natin ng 11. So, from here, ang pinakamaliit na may label ay D. So, if i-fix mo yung label na D. Then, mula kay D, ang pwede mong puntahan ay G. So, lilabelan mo yun ng 8. Sa mga may label na, ang pinakamalit na may label ay E, which is 7. So, if i-fix mo na yun, okay? So, remember, para madali mong matandaan, yung label na yan yung galing kay B. Yan. Para madaling tandaan. Ito yung label na galing kay A. Ito yung label na galing kay B. Ito yung label na galing kay A. Yan. Kasi tatlo yung possible source ni E eh. Pwedeng galing kay B, kay A, kay C. Pero yung nanalong label, yung shortest, yung galing kay B. Yan. So mula kay 7, pupunta ka sa lahat ng possible, lahat ng adjacent sa kanya. So, ang adjacent sa kanya na hindi pa na permanently label ay G tsaka H. Papunta kay G, that gives us 7 plus 1, which is 8. So, equal lang. Pag equal lang, kahit wag mo nang palitan, okay na yon. Kasi same lang naman yung magiging result. Now, on the other hand, mula kay E, pwede kang pumunta kay H plus 2. Wala pang label si H. So, ang magiging temporary label niya ay 9. So, wala nang pwedeng puntahan. So, ang mga may temporary label ay 8, 9, tsaka 11. So, ang smallest ay 8. So, fixed na siya. Magiging fixed label na siya. Hindi na siya temporary, permanent na. Now, pwedeng sabihin mo na galing siya kay D or kay E. Walang problema kasi equal lang naman din yung magiging value. So, lagay na lang natin D since siya yung una nating nakita. Yan. Okay, next. Mula kay G, pwede kang pumunta kay J. So, plus 5. So, ang temporary label ni J, magiging 13. Tapos, wala nang ibang pwedeng puntahan mula kay J. Basta, ang gagawin mo lang, iteratively, galing doon sa current vertex. Yung permanently label mo na. So, saan mo kukunin yung permanently label? Doon sa mga temporary label. So, in this case, ang mga may temporary label ay 13, yung J, yung H, tsaka yung F. Ang pinakamaliit doon is yung H. So, yun yung magiging permanent. So, permanent na yung 9. Now, from 9, saan ka pwedeng magpunta? From H. Pwede ka pumunta sa J. So, that's 9 plus 5, 14. Yung 13 mas maliit eh. So, hindi mo papalitan yung temporary label niya. Disregard. From H, pwede ka rin pumunta kay L. So, that's 9 plus 9, 18. Tama? So, temporary label niya yun since wala pa naman siyang label kanina. From H, pwede ka rin pumunta kay K. So, 9 plus 6, 15. Temporary label. From H, pwede ka rin pumunta kay F kasi hindi pa naman siya permanently label. So, 9 plus 1, 10. Mas maliit sa 11. So, papalitan mo to ng label na 10. Ibig sabihin, kung dadaan ka mula kay H, mas maigsi kaysa doon sa dumaan ka mula kay C. Kasi 10 lang kung galing ka kay H. Yan. So, since nakuha na natin lahat ng adjacent ni H, then, tapos na yung iteration na yun. Ang next, pipiliin mo ulit yung pinakamaliit na label, na temporary label, which is 10. So, yun na yung magiging fix. So, just to remember, this is from H. Yung 10 na yun. And then, from 10, pwede kang pumunta kay I. So, yung I magiging 10 plus 2, 12. So, from the temporary labels, ang pinakamaliit ay 12. So, mafi-fix na yung label ni I na 12. Galing kay F. And then, from that fixed label, pwede kang pumunta kay K. So, that's 2. So, 12 plus 2, 14. Which is smaller than 15. So, now you replace this by 14. So, ibig sabihin, mas maigsi kung manggagaling ka kay I kaysa manggagaling ka kay H. Yan. Papunta kay K. So, the temporary labels now are 13, 14, and 18. Smallest is 13. So, fix na yung 13. Yan yung galing kay G. Yan. So, kailangan tinatandaan nyo kung saan siya galing. Okay. Now, from 13, pwede kang pumunta kay L. 13 plus 5, 18. Pareho lang. So, no need to replace that. So, currently, dalawa na lang yung label natin na temporary. Yung K tsaka yung L. Now, from K, pag pumunta ka kay L plus 3, 17. So, that's an improvement. That's shorter. So, papalitan mo to ng 17. Galing kay K. And this now will be fixed. Tapos, pag pumunta kay L, fixed na rin to. Since that's the last vertex already. So, yung mga label na yan, that means, yan yung shortest possible route from A to any of these vertices to L. Ibig sabihin, ang shortest distance from A to L, 17. Now, paano mo ite-trace yung 17? That's why it's very important na alam mo yung pinanggalingan. Kaya ako nilalagyan ng label, ng subscript. Ibig sabihin, backtrace lang natin. Kung gusto mong makarating mula kay A papunta kay L on the shortest possible way, mula kay L, manggaling ka kay K. So, ito yun. Mula kay K, manggaling ka kay, hindi ko nalagyan ng subscript, pero ito galing kay I itong value na 14. Mula kay K, manggaling ka kay I. So, it's very important na properly labeled mo or tatandaan mo kung saan nanggagaling yung temporary labels mo para makip track mo kung saan ka dadaan. From I, galing yun kay F. Yung value na 10, galing kay H. Right? Yung value na 9, galing kay E. Yung value na 7, galing kay B. And then, yung value na 3, galing kay A. So, that means, that's your shortest possible route. A to B, B to E, E to H, H to F, F to I to K, and then K to L. Although it seems longer kasi maraming edges na dinaanan, but because the value of the edges here are smaller than, some values of the edges here are smaller than the other. So that's why it gives, it tends to be the shortest possible route. And that's already 17. Kanina, nung nag-compute tayo, nung naglista tayo ng dalawa, if you still can remember, yung isang value 20, yung isang value 18. Yung 20 yung straight, tapos yung 18 ito. But turns out, mas maigsi pala kung pupunta ka kay B, kay E, kay H, then bababa ka kay F, K, L. Yun pala yung mas maigsing route. Okay? Yan. So, ang tawag sa algorithm na ginawa natin, that's called the Dijkstra's algorithm. Yan. So, if you're doing a shortest path problem in your exposition, you've already probably heard of Dijkstra. So, si Dijkstra is a Dutch computer scientist, programmer, software engineer, system scientist, and pioneer in computer science. Yan. Ang pronunciation dyan ay Dike, yung J pronounced as Y. So, Dijkstra. So, pagka sa algorithm, Dijkstra's algorithm. May kulang akong S. Dapat may S to. Ito. Dijkstra. Dijkstra. Okay. So, let's summarize the algorithm. Sometimes it's helpful kung lalagay natin siya sa flowchart para mas maintindihan natin. So, ganito yung Dijkstra. Ang nangyayari, when you initialize, you need to give an initial vertex and a final vertex. So, we can name that V sub S for the starting vertex and V sub N for the terminal vertex. Yan. Okay, so, for the first iteration, maglalagay na ng value na P of V sub S. So, here P means permanent label. So, lagi ang initial permanent label, of course, 0. Kasi doon pa lang mag-start. And then, for the rest of the label, lalagyan mo siya ng temporary label na infinity. So, kanina, hindi ko na nilagay na infinity. Pero ang ibig sabihin nun, lahat ng hindi mo pa nararating, ang idea, infinite yung kailangan mong edge or distance para marating yon. In terms of graph, ang ibig sabihin, pagka infinite, unreachable. Parang ganun yung nangyayari. Okay? So, unreachable muna. So, at the moment, kasi nandun ka pa sa vertex A, kaya unreachable pa yung the rest of the vertices. So, that's the initial iteration. So, you iterate now with I equals 0. So, paano mangyayari sa susunod na iteration? Lahat ng mga vertices, lalagyan mo ngayon ng bagong label. So, paano mo lalagyan ng bagong label? Ang bagong label will be the minimum of the previous label. So, ang mga previous label niya, kung mapapansin natin sa initial condition, T of V is lahat infinite. Okay. So, either yung previous label niya na infinity or yung bagong label niya which is this formula. Permanent label nung vertex 0, yung initial vertex natin, plus yung weight papunta from vertex 0 to that vertex. Now, kung yung vertex na yon ay adjacent, then the value will be constant kung adjacent yung dalawang vertex. Mula dun sa initial vertex, papunta dun sa next vertex, V sub J. Now, kung yung vertex na yon ay hindi adjacent, unreachable siya. So, infinite yung value. So, lahat ng adjacent magkakaroon ng bagong value. Comparing sa infinity, mababago yung label because of this iteration. So, yun yung ginawa natin kanina. From A, kinuha natin yung mga adjacent. Tama? Kinuha natin yung mga adjacent. So, mga adjacent dito, yung B, yung E, yung C. Nilabelan natin siya ng 3, 9, and 2 respectively. The rest, infinite, kasi unreachable from A. From A, hindi ka pwedeng pumunta agad kay D kasi wala namang edge papunta doon. Kaya unreachable. Okay? So, ganun yung mangyayari. Papalitan mo yung label ng lahat ng reachable kasi magiging ang minimum nun, ito infinite lahat to sa unang iteration. So, next. So, na-labelan mo na ulit, na-relabel mo na lahat. So, once na na-relabel mo na lahat, kunin mo yung minimum doon sa mga temporary label, ipe-permanent mo na siya. Minimum of all the temporary label becomes the permanent label of that vertex. So, siya na yung tatawagin mong vertex sub 1. Okay? So, vertex sub 0 yung kanina, this time vertex sub 1. So, sa example natin, yan yung naging vertex C. Next, dadagdagan mo ulit yung value ng A for the next iteration. Yan. So, syempre, may decision path. yung I mo ba ay number of vertices minus 1 na. Kasi pag ang I mo, number of vertices minus 1, ibig sabihin, napunta mo na lahat ng vertex. Tama? Kasi binibilang mo nilalagyan mo V sub 0, V sub 1, V sub 2. Kung meron kang n vertices, pag nakarating ka na sa V sub n minus 1, tapos ka na kasi napunta mo na lahat. So hanggat hindi pa, hanggat less than pa yan, babalik ka dito sa iteration na to. So anong iteration yon? I-relabel mo lahat, tama? I-fix mo, kanina, finix mo, yung huli mong ginawa, finix mo na yung bagong label. So from the old label, from this label, iikot ulit yung iteration, hahanapin mo ulit yung mga bagong label mula dun sa P sub V sub J, B sub I. So doon ka na ulit mag-i-start. Re-relabel mo lahat ng reachable, papalitan mo ng label, lahat ng unreachable, infinite pa rin. Pero kung may label na yon, i-compare mo, alin yung mas maliit? Yung lumang label o yung bagong label? So kung alin yung mas maliit, yun yung kukunin mo as the new temporary label. Temporary pa lang. Okay. And then again, sa lahat ng mga may label na, except yung mga infinite pa rin, kung ano may minimum, yun yung magiging sunod na fix. O, di nasa V sub 2 na yun. And then iteration ulit. Yung I ba ay mas maliit pa rin sa n minus 1. Kung hindi pa, iterate ka pa. Kung equal na, ay kung oo, maliit pa, iteration ulit. Pero kung equal na, tapos na. O, di, kung nasa V sub 2 ka na, if-fix mo na yung V sub 2, then from V sub 2, relabel ulit. Relabel. This process is relabeling. Nire-relabel mo yung temporary label. So after you get a temporary label, get the minimum of all the temporary label to fix that label. And then decide kung tapos na ba o hindi pa. Kung mas maliit pa rin yung I kaysa sa n-1, ikot ulit. Ikot ulit. Until ma-reach mo na yung terminal point na I equals n-1. Ibig sabihin, andito ka na sa final vertex. Tapos na kasi ito na yung n vertices. Wala na, tapos na. Okay? So that's the idea. Basta nadaanan mo na lahat ng vertex, tapos na. So once tapos na yung algorithm, meron ka ng label ng lahat ng vertices. So that's what Dijkstra algorithm is. Okay? Yan. So ang mahalagang part is the labeling. This one. So ikot ka lang ng ikot until you visited all the... So when I say visited, yun yung mga may label na. Yan. Okay, now, you can also do the Dijkstra algorithm in a tableau, in a table. So, minsan, kung mas madali sa inyo na sinasummarize or ako, I find it easier kasi lahat ng information nalilista sa table. Unlike doon sa graph, minsan it's limited. You're being limited by the size of your graph. Okay. So, let's try to perform again Dijkstra algorithm. Pero this time, let's put all the values dun sa table. Okay, so ganito yung nangyayari. So again, you start with your initial vertex. So our initial vertex is A. So always, the initial vertex, so ito yung mga vertex to visit. Vertex to visit. Tapos, itong mga nandito, yung mga visited. Yung na-visit na natin. So, pag visited na siya, hindi mo na siya babalikan. So, that's the idea. Hindi ka na babalik. So, ang una mong i-visit, yung initial vertex mo. So, always, ang distance nun, 0. Now, so that we know kung saan tayo nanggaling, lalagyan natin ng subscript kung saan galing. So, we're from vertex A, kaya 0 sub A. Ibig sabihin, mula kay A, para makarating ako kay A, kailangan ko ng 0 na distance. Yun yung ibig sabihin nun. Now, always, this is the fixed distance for the initial, fixed label for our initial vertex. Lagi yon. Lagi. Always. So, wala ka pang kailangang isipin dyan. Laging 0 ang initial vertex. Which is sensible naman, di ba? Siyempre, wala ka pang pinupuntahan. 0 pa. Okay. So, lahat ng hindi mo pa napupuntahan, magiging unreachable yun. Yan. So from A, you start walking now or you start visiting the edges that you can visit. Now, lahat ng pwede mong mabisit, lalagyan mo lang ng weight. So, ang weight papunta kay B ay 3. Lalagyan ko, galing ako kay A. Mamaya magiging helpful yung subscript na yan. Para makip track ninyo kung saan kayo galing. Si E, pwede kong puntahan, galing kay A, may 9. Yan. Okay. Si C, pwede kong puntahan, 2. The rest, hindi ko kayang puntahan from A. So, infinite yung weight niya. So, ito yung ginawa natin. Yan. So, ito yung first step. 0 muna, infinite lahat. Yung next step, mula kay initial vertex, lalabelan mo na siya. Kung pwede siyang puntahan, lalagyan mo na ang weight. Kung hindi pwedeng puntahan, infinite pa din. Okay? So, yun yung nangyari. Yan. Okay. So, since kaya kong puntahan, yung BCE, lalagyan ko ng 3, 2, 9. Lalagyan ko ng subscript A so that I can keep track kung saan ako galing. The rest, infinite na. Now, from here, makikita natin na ang minimum na label ay na kay C. So, si 2A, if-fix ko na as label ni C. So, fix na siya. So, ang susunod kong bibisitahin yung C. So, right now, nakay vertex C ako. Okay? So, right now, nandito ako. Fix na to. 2A. Yan. So, right now, from vertex C, bilugan ko para hindi ko na mabalikan. Okay? Or square. Square pala ginamit ko. Para consistent. Ayan. Ayan. Okay. From C, pwede kong ma-reach ang E tsaka ang F. Tama? So, si E, pwede kong ma-reach by 2 plus 6. So, 8 galing kay C. Now, since mas maliit siya kay E, ma-overwrite niya yung 9A. Kasi mas maliit yung 8 kaysa sa 9. Pwede akong pumunta kay F. So, that's 2 plus 9, 11. Infinite. So, mas maliit yung 11. So, ma-overwrite ko na to, magiging 11C. Now, hindi ako pwedeng pumunta kay B galing kay C. So, ibig sabihin, ang value ng C to B, infinity. Eh, mas maliit yung 3A. So, makikip yung 3A. Kasi infinity yung isusulat ko kung galing ako kay C. Okay. Hindi ko na ibibisit si A kasi may label na siya. Now, the rest, unreachable na. Yung D, yung G, yung J. So, lahat yun, infinite pa din. Kasi unreachable sila galing kay C. Okay? So now, you decide alin yung mas maliit, siya yung magiging fixed na label. So pinakamaliit dito is 3A, so mafi-fix na yung label na 3A ni B. Now, we start the algorithm from B this time. Ulit-ulit, ganun ulit. Relabel ulit. So ulitin mo ulit, this time from B. Hindi ka na pupunta kay C, kasi may label na si C, so D to L na. So from D, so this time, this is now labeled as 3A. Yan. From B, pwede akong pumunta kay D plus 2. Now, that's smaller than infinity. So, papalitan ko yung label na to. So, magiging 5 galing kay B. Pwede akong pumunta kay E. That's, ang B ay 3 plus 4, 7. 7 is smaller than 8. So, papalitan ko ulit yung label ng 7B. The rest ay unreachable mula kay B. So, infinite. Basta unreachable, infinite. Then, choose the smallest value. Ang smallest value ay 5B. So, 5B now is fixed. Let's mark this. 5B. Fixed na yan. So, this time, we'll start with D. From D, relabel again. So, ang pwede lang natin puntahan from D ay G. So, from D, pwede ako makarating kay G from 5 plus 3. So, this is 8 sub D. The rest are unreachable from D. Lahat ng mga unlabeled, unreachable from D. So, since infinity is bigger than 7b, keep ko to. Papalitan mo lang yung label pag mas maliit yung magiging label. Pero galing kay D, papunta kay E, infinite. E de mas malaki yon. E de keep mo yung 7b. The rest, infinity na. Yan. So, kumbaga, initially, lahat ng weight niyan, infinity. Mapapalitan mo lang yon pag na-visit mo na yon. Yan. So, ganyan yung idea. Okay? Now, smallest is 7. Right? So, yung 7, fixed na. 7 from B. Yun yung smallest 7B. So, this time, you start from E. Kasi paulit-ulit na lang to, di ba? Kumbaga, basta nakuha mo na yung momentum, kayang-kaya mo nang ituloy. Alright. Now, tuloy natin. From E, ano mga pwede mong puntahan? Yung mga unvisited. G lang tsaka H. Ang G plus 1. Ang H plus 2. So, 7 plus 1, 8. So, again, pareho lang ng value. So, kahit hindi mo napalitan, okay lang. Papalitan mo lang kung less than. Yan. Pero at this point, pag equal, it doesn't matter kung palitan mo. Walang problema. Para walang makukuha. So, either you write that as 8B or 8E, it doesn't matter. Now, EH gives us 2 rather. The weight is 2. So, 7 plus 2 is 9. So, this now has 9E. Now, the rest are unreachable. So, infinite pa rin. Ay, sorry. May label na pala to kanina na 11C. So, dapat keep mo yung 11C kasi mas maliit yung 11C. Yan. So, nakatulong na nakalist in a table kasi na-figure out agad natin yung mali natin. So, again, once na nagka-label siya, versus infinity, mas maliit yung label na yan. Yan. Okay. The smallest currently unlabeled vertices is 8D. So, yun ay magiging fix. So, ang susunod na fix ay G. Okay. From G, ano mga pwede natin puntahan? Si J lang. And that's weight 5. So, we're now starting from G. Okay. Pwede natin puntahan si J plus 5. So, 8 plus 5, 13 from G. Wala nang ibang kayang puntahan. So, just keep the label ng mga hindi na kayang puntahan. 11C, 9F, infinity, infinity, infinity. The smallest is 9F. So, we fix 9F. Kung ano yung smallest, yun yung i-fix. So, we're now starting from H. Now, H here, ito. So, 9F. Ay, 9E. Sorry. Tama? 9E. This is from E. From E. Na typo error lang. Yan. Tama? Okay. Next. From H rather, ang mga pwede nating puntahan ay si J, si L, si K, tsaka si F. Papunta kay J plus 5. So, 9 plus 5, 14. 13 na yung nandun. So, hindi mo napapalitan. Papunta kay L, 9 plus 9, 18. Si L wala pa. So, that's 18 galing kay H. Papunta kay K, 9 plus 6, 15. Si K wala pa. So, lalagyan natin 15 galing kay H. Papunta kay F, that's 9 plus 1. So, that's 10. Si F, may 11. Mas maliit yung 10. So, papalitan natin. 10H. Kasi mas maliit. The rest, if i-fix, kakopy mo lang yung label niya. 18. Kasi unreachable na the rest So, unreachable yung I. Tama? Tapos, yung J, reachable, pero mas malaki, kaya hindi natin pinalitan. So, 13. G. Okay? Then, choose the smallest value. 10H. So, 10H is now fixed. And now, we're starting from F. So, yung F natin, 10H. Now, from 10H, pwede tayong pumunta sa I plus 2. So, I is plus 2. So, 12 from F. The rest, unreachable from F. So, since unreachable, copy lang. 13G, 15H, 18H. This time, the smallest is F. So, we're fixing F. Now, we're fixing 12F. So, now we're starting at I. So, this is 12 galing kay F. Fix. Now, from I, pwede tayong pumunta kay K. That's plus 2. So, 12 plus 2 is 14. Smaller yan. So, papalitan natin to. So, 12 plus 2, 14 galing kay I. The rest are unreachable. Hindi tayo makarating kay J tsaka kay L. So, copy lang. 13G, 18H. This time, the smallest value is 13. So, we're now fixing 13G. And that's actually vertex J. So, si vertex J ay 13G. Okay. Next. From 13G, which is J, punta tayo sa mga reachable. Ang reachable lang yung L. 13 plus 5, 18 from J. So, magkaka-18 doon. Tama? 18J. Okay. So, 13 plus 5 is that 13 plus 5, 18. So, that's the same. So, no need to replace. Pareho lang din naman. And then, this is copy since unreachable. Now, the smaller of the two value is 14, of course. So, this is now fixed. This is 14 from I. Right? I. So, that's fixed. And that's vertex K. And then from K, pwede mo na lang puntahan ay L plus 3. Now, that's an improvement. So, papalitan mo siya ng 17 from L. From K. So, that's the fixed value. Which is actually your last vertex L. Yeah. So, this is, papalitan mo ng 17 L. K. Okay? So, this table now gives us the result of our labeling. So, ano sinasabi ng table na to? This actually tells us not just the shortest path, but all the shortest path from A to L. Hindi lang from A to L, kundi from the rest of the vertices. So, sinasabi ng label na to, kung gusto mong pumunta from A, papunta kay G, papunta rito, ang shortest path ay 8 galing kay D. So, punta ka kay D. Kung gusto mong makarating from A, papunta kay D, ang shortest path ay 5 galing kay B. So, punta ka kay B. Kung gusto mong makarating kay B, galing kay A, ang shortest path 3. So, from A to G, ang shortest path ito. Yun yung shortest path. So, yun yung label. Lahat ng shortest path from A. Diba? Gusto mong pumunta kay K. So, papunta daw kay K, o wag mo na si K, si J. Papunta kay J, ang shortest path daw, 13, galing kay G. So, ito yun. And then, backtrace mo ulit. So, that's why it's very important yung subscript. Para ma-backtrace mo kung saan ka dapat dadaan. So, ultimately, kung gusto mong pumunta kay L, galing kay A, ang shortest path will be from 17, from L, manggaling ka kay K. So, dito yun. Then si K, para makarating ka kay K, galing kay A, ang shortest path niya, manggaling ka kay I. Si I, ang shortest path from A manggaling kay F. Si F, ang shortest path from A manggagaling kay H. Si H, ang shortest path from A manggagaling kay E. Si E, ang shortest path from A manggagaling kay B. Subscript niya B. Tapos si B manggagaling kay A. So that's your path. That's your shortest path from A to L. So again, it doesn't just tells us the shortest path directly from A to L, but also the shortest path from A to any of the vertices in the graph. Okay? So if you also want to get the shortest path from A to any vertices of the graph, na-compute mo na rin yun using this algorithm. Now, sir, what if I want to compute the shortest path from B to F? So, hindi mo pwedeng gamitin yung ginamit mo kay A because it requires now a different algorithm. Why? Kasi ang starting point mo na B. So, kung ang tanong mo is from B to any of the vertices, mag-start ka ulit ng Dijkstra. Magda-Dijkstra ulit, this time from B naman. So, kung galing kay H, ang gusto mo, initialize mo kay H, to any of the vertices, kay H mo naman gagawin yung Dijkstra. And so on. So again, pag nagawa mo yung Dijkstra from one vertex, ibibigay na niya lahat ng shortest path from that vertex to any of the vertices in our graph. Okay? Now, sa table, ganun din. That's easy to figure out kahit wala yung graph. On table lang. For example, you want to determine the shortest path from A to H. So, mula daw kay A, papunta kay H. So, dito mo gustong pumunta. So, kikip track mo yung label ni H. Yan. Ang label ni H ay ito. Yun yung label ni H. So, sabi, from H daw, dapat manggagaling ka kay E. So, hanapin mo si E. So, ito si E. Ang label niya ito. 7B. So, dapat, mula kay E, manggaling ka kay B. Ito, hanapin mo si B. Ito si B. Ang label niya, 3 sub A. So, galing kay B, manggaling kay daw kay A. Now, yung path length mo, dito, 9. So, summative yun, ha. Mula kay A, papunta kay B, plus 3. So, 0, magiging 3. Tapos, ang label ni E, 7. Ibig sabihin, from B to E, ang length nun, 4. From B to A, ang length nun, 3. Si H, ang label niya 9. Ang ibig sabihin nun, from E to H ay 2. Okay? So, yung label na nakikita natin, yun na yung total distance. Kung gusto mo makita yung weight ng kada edge, isusubtract mo lang. So, 9 minus 7, 2. So, ibig sabihin, from I to H, 2. 7 minus 3 is 4. So, from B to E is 4. And then, 3 minus 0 is 3. So, B to A is 3. So, lahat ng information ng graph nandito na rin sa table. You just have to know what the entries in the table means. So, lahat din ng adjacent kay E, makikita mo sa table. Kasi pag hindi infinite. Kaya lang, pag napalitan yung value, halimbawa, itong value na to, 11C, na-carry over dito. So, ang ibig sabihin nun, either katabi ni E si F, pero mas malaki yung value niya, kaya 11C yung nakip, or hindi niya katabi. Kaya infinite yung value niya. So, now, for those information, medyo kailangan mo ng graph para ma-figure out informations na yun. Pero pag infinite, automatic alam mo na hindi niya katabi. Kasi infinite yung naging value. Ibig sabihin, unreachable. Yan. So, again, we start with all the possible vertex and then we visit each vertex. Then once we visited that vertex, we fix that vertex. Now, ang decision maker, kung i-visit mo yung vertex na yun or not, if that is the smallest temporary label of the vertices. So, for example, here, the smallest is 2, kaya ang next mong binisit, yung 2. So, C yung next mong linisin. Okay? Then, from the labels 3 to infinity 8, 11, ang smallest ay 3. Kaya yung susunod mong i-visit, hindi nakasama yung 2 kasi na-visit. Currently, nasa 2 ko eh. Nasa C rather. Ang susunod mo i-visit, yung pinakamaliit. Sa 3, sa 8, sa 11, which is 3. Kaya ang susunod mo i-visit, yung B. So, from B, i-relabel mo lahat ng unvisited. So, ganyan lagi. Label all the unvisited, visit the next smallest label, and then from there, fix that label, and then label the unvisited, fix the smallest, then visit that, and so on and so forth. Ulit-ulit na. So, ganyan lang kadali yung Dijkstra algorithm. Okay? So, from our Dijkstra again, you can complete the table from A up to any of the vertices. So, I'll just leave this as an exercise. So, ang gagawin nyo lang, pupunta ka sa D. So, titignan mo yung table. Paano ka makakarating kay D from A? Ano ginawa ko kanina? So, mula kay D, dapat galing ka kay B. Tapos mula kay, ito yun. Tapos mula kay B, dapat galing ka kay A. So, ipa-follow mo lang. So, A, B, D. So, lalagay mo lang dito. A, B, D. And then the path length is label ni D. Diba? O ano may label ni D? Ano ba label ni D? Ang label ni D ay 5. Lalagay mo dito, 5. Now, E, titingnan mo yung label ni E. Sabi, ang label ni E, 7 sub B. So, alam mo na yung path length, 7, galing siya kay B. Meron na tayong listahan pag galing ka kay B. A, B, E. So, para makarating ka kay E, manggagaling ka kay B. Para makarating ka kay B, manggagaling ka kay A. Total of 7. Okay? So, just complete the table here. Yan. As an exercise. Para makita nyo kung ano yung path na dadaanan to find the shortest path from A to any of the vertices in the graph. Again, remember, this is from A to any of the vertices in the graph. Yan. Next is the critical path problem. Now, this is very similar to the shortest path problem, but in a way, it's totally the opposite. Yan. So, what's a critical path problem? Now, to have an idea of a critical path problem, let's see we want to build a house. Okay. So, pag nagbi-build tayo ng house, may iba't ibang activities yun eh. Hindi naman isang bagsak house agad, di ba? So, building a house requires several different activities, like laying the foundation, putting the roof, putting up the wall, installing the wirings, installing the pipes, plastering, di ba? Tiling, cabinet fixtures, etc. So, if you have an idea on how to build a house, yan yung mga iba't ibang activity. And those activities, some of them are dependent on finishing one of the activities first before you can start the next activity. May mga ganyan eh. Ibig sabihin may predecessor or may dependencies. For example, let's use the graph to illustrate. Pag mag-build ka ng house, so pwede kang gumawa ng septic tank, mag-lay ng foundations, mag-welding ng roof independently. Ibig sabihin, pwede mong hiwa-hiwalay. May gumagawa ng foundations, may gumagawa ng roof frames, may gumagawa ng septic tank. Hiwa-hiwalay. Tama? So, all of them are needed to start building a house. So, from the start, pag naglagay ka ng arrow, ibig sabihin, yun na yung next mong gagawin. So, from the start, pwedeng some are doing septic tank, some are doing the foundation, some are doing the roofs, the roof frame. Now, pag may roof frame ka na, tsaka mo lang pwedeng gawin yung roof. Pero hindi mo pwedeng gawin yung roof hanggat hindi mo na bibuild yung foundations. Kasi kailangan mo ng poste, di ba? Okay? So, kumbaga, we build up from the base up. So, for example, dito may nagwe-welding ng roof frame. Okay, may magwe-welding diyan ng roof frame. Wine-welding muna 'yan eh. Hindi naman yung bakal iaakyat doon sa bubong, di ba? We-weldingin muna individually. Tapos dito may gumagawa ng foundations. Ibig sabihin, tinatayo nila yung poste. Kung saan ikakabit yung, parang yan yung mga biga. Yan. Okay? So hanggat wala yan, hindi mo pwedeng gawin yung walls. Hindi pwedeng mag-e-erect ka ng walls nang wala yung foundations. So kailangan mauna yung foundations. Hindi mo rin pwedeng gawin yung roof. Yan. So, dependent yung paggawa ng walls tsaka ng roof doon sa foundation. So, ibig sabihin, kailangan matapos muna yung foundations bago mo gawin yung wall. So, yun yung ibig sabihin sa dependencies. Now, yung roof, dalawa yung kailangan munang matapos. Kailangan matapos muna yung foundations at tsaka kailangan na welding na yung frame bago mo gawin yung roof. So, once may walls ka na, may roof ka na, pwede ka nang mag-pipings. Yan. Pero yung piping, siyempre kailangan may septic tank ka. Para alam mo kung saan pupunta yung pipes, di ba? So it's very important na may septic ka na. May drainage system ka na. Yan. So kakabit mo na yung pipings, wirings. So pag meron ka ng wall, tsaka roof, pwede ka na magkabit ng wirings. Now, bakit required na may roof muna bago mag-wirings? Siyempre, pag naglatag ka ng wirings ng exposed, tapos umulan, di ba? So, sayang yung wirings mo, mababasa. So, kailangan may roof ka muna. Similarly, may wirings din sa kisame eh. So, kailangan tapos na yung roof bago mo ilagay yung wirings para sa ilaw and so on. So, that's the idea. Okay? So, yung mga set of activities, mga nakadepende, bago magsimula yung iba, kailangan matapos muna yung iba. Pero there are also activities that you can do while doing other stuff. So, pwede rin magkakasabay, pwedeng independent, and so on. Now, the question now is this. Can we find an efficient method for determining how to schedule the activities so that the entire job is completed in the minimum time? Yan. So, minimize natin yung time. Ibig sabihin, gusto mong i-schedule na, kailan natin ilalagay yung foundations, kailan natin gagawin yung wall, kailan natin ikakabit yung ceiling, kailan natin, and so on and so forth. So, kumbaga, yung activity mo, kailangan ma-schedule mo properly. From day 0, ano na dapat yung ginagawa mo? From day 1, day 2, day 3, day 4. Dapat alam mo kung ano yung ginagawa ng mga tauhan mo. So, that's the idea. Kailan mo gagawin yung mga dapat mong gawin? Because some of those activities required na matapos muna bago mo gawin yung susunod na activities, some are not. So, dapat maayos mong ma-schedule. Likewise, may mga activities doon na tinatawag natin critical. What do you mean by critical? Merong activities doon na pag na-delay, yung buong time ng project madi-delay. So may mga ganong activities. So how do we determine yung mga activities na yun so that we can keep track? Yan. So this process is very important yung pag-schedule, especially in project management. Yeah. Since you're in computer science, most probably, yung mga project management ito, halimbawa, magbi-build ka ng network. So, ano yung mga dapat schedule mo pag magbi-build ka ng network? Pag mag-set up ka ng router, yan. Pag mag-set up ka ng internet connection sa isang lugar. So, may mga series of steps na kailangan kang gawin. Pag magbi-build ka ng program, ng software, ano muna yung kailangan mong simulan? Yan. Pag mag-set up ka ng computer, so yung idea ng critical path problem is on project management. Paano mo i-manage properly yung schedule? So that, by that schedule, you complete the whole project in the minimum time, in the least possible time. Okay? So, yun yung idea. So, pwede nating tingnan ito as a directed graph, a diagram, right? So, you can imagine na yung A is the starting point and yung L is the finish point. So, may mga activity that you can do simultaneously. So, if you imagine, parang yung A to E, that's building the foundations. Yung A to B, that's building the septic tank. Yung A to C, that's welding the roof frame, and so on. So, ganun din yung idea. So, ang idea, pag may arrow, ibig sabihin, dependent na matapos mo yung activity from A to C bago mo masimulan yung C. Ganon din yung A to E. Bago mo masimulan yung, so ibig sabihin, from A to B, there's an activity here. So the start of that activity is point A and the end of that activity is point B. So before you can start activity B to D, you must finish first activity B bago mo ma-start yung activity na to. So ganun yung nangyayari. So dependent yung D tsaka yung E sa activity B. Dependent yung E sa activity BAC. Dependent yung C sa activity A, and so on. Yan. So the weighted diagram here represent an activity network na tinatawag. So when you say activity network, ano lang yon, diagram that shows you the dependence of the activity. In which each edge represent the length of time taken for an activity to finish. So, yung mga markings natin dyan, 3, 9, 2, yan yung time required to finish activity from A to E. Yan. Sometimes, ang iba, ang nilalagay nila yung activity sa edge. Parang ganyan yung ginagawa nila. Halimbawa, start. Tapos maglalagay sila ng name ng edge. This is septic, halimbawa. This is foundations. And then this is, for example, this is, ano susunod na activity natin? Roof frame. Tapos sa dulo, ibig sabihin, natapos yung activity after 3 days. Halimbawa, foundation say 9 days, roof say 2 days. Yan. Yan. So from here, tsaka mo isusunod yung susunod na mga activity. So, yung iba, ganun yung ginagawa. Yan. In project management, especially if you're talking of a business proposal, let's say. So, pag business proposal, kailangan ipapakita mo yung projection kung kailan matatapos. So, ginagamit din nila, ang label na ginagamit nila ay 1, 2, 3 to name the activities or ABC. Pero yung ABC nila, yung pag-label, dapat yung 1 nakaturo sa mas malaking number. So, hindi pwedeng, halimbawa, yung 2 nakaturo sa 1. Kumbaga, inaayos nila yung set of activities na 1. So, tuturo siya sa 2, tuturo to sa 3, sa 4. Yan. So, those are possible labeling. Tapos yung 2, tuturo sa nagamit mo na 4, di ba? 5. So, halimbawa, may 6 dyan, nakaturo din. Yan. So, kumbaga, from left to right, the numberings are arranged in increasing order. Para dun sa pagle-label nila, mas madali nilang nakikita yung precedence ng activities. Okay, so those are the possible labeling. But anyway, ang mahalaga lang naman is you understand your label. Yan. So here, some of these activities can be prepared simultaneously, while some may need to be completed before. So yung arrow signify the dependence. Yan. So vertex A always represent the beginning of the job. So lagi nasa left yung beginning ng job, tapos lagi nasa right yung end ng job. And lahat dapat magsimula sa A, tapos lahat dapat matapos sa L. So for example, may activity ka na kailangan gawin independent of the rest. Parang isang activity lang siya. Iko-connect mo pa rin siya sa A kasi kailangan niyang mag-start. Tapos, iko-connect mo pa rin siya sa dulo kasi kailangan niya mag-end. So, laging ganun yung activity network. It always starts from one point and it always starts from one point as well. So, point to point lagi yung pagtingin. Okay? So, ang idea, gusto nating hanapin yung minimum time to finish the job. Pero syempre, di ba, dapat daanan mo lahat eh. Kasi this is a job na kailangan makompleto. So, dapat dadaanan mo lahat. Ibig sabihin, when you trace an arrow, dadaanan mo lahat yung path na yan. Yan. For example, yun yung tinry mong path. O yung path na to. O yung path na to. Kasi kailangan madaanan mo lahat eh. Yan. So, no matter. Kumbaga, merong isang tao na gagawa ng sunod-sunod na yon. So, that's the idea. So, dinadaanan mo lahat. Right? So, ibig sabihin, meron diyang isang longest path. Yung longest path na yon, ang ibig sabihin nun, yun yung path na pinakamatagal mong magagawa. Right? Pag dumaan ka sa path na yun, yung path na pinakamatagal mong magagawa. So, that means, yun yung critical na path. Meaning, kailangan tapusin mo siya on that particular schedule. So, meaning, yun na yung minimum amount of time na matatapos mo yung project. Yung longest path. Why? Kasi, pwede naman na from this, di ba, sabi, yung isang path hindi pa tapos, mag-iintay muna ako hanggang matapos yung path. Pag may na-delay doon sa path na yon, pwedeng humaba yung schedule. Pero yung longest path, that will be the minimum time na matatapos mo yung project. Kasi hanggat hindi natatapos yung path na yon, hindi tapos yung project. Right? And you cannot shorter that path anymore. Hindi mo pwedeng paigsiin yung path na yun eh. Kasi that's a path from A to L, which is required na madaanan mo. So, ang idea, ang hinahanap natin, yung longest path. The entire job cannot be completed until each path from A to L is traversed. Kailangan daanan mo lahat ng path eh. Kasi kailangan magawa lahat ng path. So, yung pinakamahabang path na nadaanan mo, that's the critical path. So, hanggat hindi tapos yung path na yon, hindi tapos yung project. So, that's the minimum amount of time that you can finish the project. Ulitin ko that's the minimum amount of time to finish the project. Kasi hanggat hindi tapos yung path na yon, hindi tapos yung project. Pag may na-delay sa path na yon, hahaba yung project. So, kaya siya yung minimum amount of time. Pero in terms of the graph, siya yung longest path. Yan. So, how do we find the longest path? So, we have here an algorithm called Program Evaluation and Review Technique, or PERT. Yan. It's a tool used in project management designed to analyze and represent the tasks involved in completing a given project and to identify the minimum time needed to complete the total project. Yan. Commonly used siya sa mga business related activities, but actually it's used in almost all activity that requires project management. Kahit architect ka, kailangan mong mag-project manage. Kailangan alam mo kung kailan mo sisimulan yung pagtayo ng building. Kahit engineer ka, meron kang project, gagawa ka ng dam, gagawa ka ng building. So, ganun pa din. Isa-isa pa rin yung activity. Kahit computer science major ka, kahit business application major ka, kahit statistic major ka, kailangan marunong kang mag-manage ng project. So, this is a very important application in project management. So, ang idea, kamukha lang sa Dijkstra algorithm, ang gagawin mo lang, you move across from left to right, kasi may arrow to eh. So, kailangan susundan mo yung direction ng arrow. So, in this particular graph, hindi ka pwede bumalik sa arrow ha. Kasi directional yung arrow. So, you follow the arrow from left to right, then we associate with each vertex B a label indicating the length of the longest path. So, kanina, habang tinitrace natin yung arrow, kinuha natin yung shortest. This time, ang kukunin mo, yung longest. So, baliktad lang. Pero same algorithm, same concept. Instead of shortest, get the longest. Yan. And then you visit each path as you label them. Bibisit mo yung kada path na hindi pa nalalabelan. Pero laging ang pipiliin mo, longest. Yan. So, sa PERT, longest lagi. So, ganito yung idea. So, let's say we have the same graph. So, assign LA, temporary label sa A, you're starting as 0. So, ganun pa din. Ito temporary label mo siya as 0. Okay? And then, you check the dependencies of each vertex. So, ano ang mga nakadependent kay A? So, from A, pwede mong gawin si B, yan, si E or si C. Now, kung pupunta tayo kay B, Okay? Makikita natin si B, dependent siya kay A. So, ibig sabihin nun, kailangan matapos mo yung A bago ka makarating kay B. Now, that activity, sabi, required 3. So, ang magiging label ni B is label ni A plus yung time required from A to B. So, from start to finishing B. So, that means it's 0 plus 3 or 3. So, ganun ulit. Kamukha lang din nung sa Dijkstra algorithm. Now, since wala nang iba pang dependency si B, di ba? Basta natapos mo na yung A to B, wala nang ibang nakadependent, fix na yung label na yon. So, this time, mas mabilis mag-decide kung fix na ang label. Ang titingnan mo lang, saan dependent yon, yung activity B. So, dependent lang siya kay activity A, so fix na siya na 3. Galing kay A. Okay? Now, look at vertex C. Dependent lang siya kay A. So, that means, from A, kailangan mo lang ng weight of 2 or time equals 2 para matapos yung edge na yon, para makarating ka kay C. So, that means, ang label ni C is label ni A plus yung time spent from A to C. So, that is 0 plus 2. So, fix na yon. Again, dito, ang pagde-decide ng fix, kung ano yung mga dependent, kung saan siya dependent. Yan, kung saan siya dependent. Eh, sa A lang naman siya dependent. So, tapos na. Ibig sabihin, wala ka nang hinihintay. Wala ka nang hinihintay. Okay. Now, let's go to D. So, si D dependent lang kay B. So, you label it 3 plus 2. So, 5. Galing kay B. Again, kasi wala nang iniintay si D. Okay, si E naman, dependent siya kay B, kay A, tsaka kay C. Now, bago matapos si E galing kay B, kailangan mo ng 3 plus 4. So, 7 ang kailangang intayin ni E. Galing kay A, ang kailangan niyang intayin, 9. Galing kay C, ang kailangan intayin, 2 plus 6, 8. So, bago magsimula yung E, kailangan matapos muna yung B, yung A, tsaka yung C. Pero si A ang pinakamatagal. So, hindi mag-i-start si E kahit tapos na si B or si C hanggat hindi tapos si A. Right? Kasi dependent si E dun sa tatlo eh. So, yun yung idea. Hindi mag-i-start si E hanggat hindi natatapos si B, hanggat hindi tapos si A papunta kay E, hanggat hindi tapos si C papunta kay E. Dahil ang pinakamatagal ay 9, so required na 9 bago magsimula si E. So, galing kay A. So, again, kabaligtaran ha. Kanina, ang hinahanap natin, shortest. This time, ang hinahanap natin, longest. Okay. Next. So, ito kahit saan ka magsimula, basta titingnan mo lang yung dependencies niya. For example, pwede na ba ako kay L? Hindi pa, kasi kailangan ko muna si J, si H, this is H, tsaka si K bago ko ma-decide yung time ni L eh. So, sunod-sunod, pero pwede ka mamili kung si G ba muna, si H, or si F. Wala namang problema. Basta determined na yung dependencies niya. For example, pwede kong simulan kay H. Ang dependencies ni H ay E lang naman. So, plus 2. So, si H ay 9 plus 2. 11 galing kay E. 11 galing kay E. Right. Si G, ang dependencies niya ay D tsaka E. So, galing kay D, 5 plus 3, 8. Galing kay E, 9 plus 1, 10. Sino ang mas malaki? Yung galing kay E. So, si G ay magiging 10 galing kay E. Kasi kahit matapos mo yung D, hindi pa rin mag-i-start yung G hanggat hindi tapos yung E. Kaya ang magiging label niya yung mas malaki. Alright. Now, yung F, dependent lang siya kay C. Plus 9. So, 2 plus 9, 11C. Yung J, dependent siya kay D tsaka kay H. G rather. So, G is 10 plus 5, 15. From H is 11 plus 5, 16. Sino mas malaki? 16. So, this is 16H. Hindi ba pwede si L? Kasi wala pa yung K. So, si I galing kay F plus 2. So, that's 13 galing kay F. Si K, dependent siya kay H saka kay I. Pag galing kay H, 11 plus 6, 17. Pag galing kay I, 13 plus 2, 15. Mas matagal yung galing kay H. So, 17K. Right. Now, si 5, si L rather, from J, 16 plus 5, 21. From H, 11 plus 9, 20. From K, 17 plus 3, 20. So, mas mahaba yung 21. So, 21 galing kay J. So, that's how PERT works. You get the longer time to finish dun sa mga dependencies niya. Saan siya nakadepende bago siya matapos? You get those time and then you choose the longest. You choose the longest. So that means, ang pinakamaaga na pwedeng matapos yung project, 21, assuming you keep track with your schedule. Kasi yun na yung longest path yung 21. So how do you determine the longest path? You backtrace again. 21, makukuha mo yon from J. So ito siya. So backtrace natin. L, J. Yung J ay 16H. Galing kay H. So dito siya galing. H. Yung H ay galing kay, alam naman sa mahaba, 11E. So ito daw, 11E. Now, si E ang pinakamahaba from A. So that means that's your longest path. A to E to H to J to L. And it will take you 21 unit of time. So kung bawat day yan, 21 days. So take note na kahit natapos mo agad again yung B or yung C, hindi mo ma-start yung E kasi hindi pa tapos si A. So kailangan tapusin mo muna yung A to E bago masimulan mo yung E. Right? So any path aside from this path will be either the same amount of day or shorter day to take. For example, gagawin mo yung A to B, that's 3. Plus B to D, gagawin mo na yung B to D, so that's 2, 5. Plus from D to G, gagawin mo na, so that's plus 3, so that's 8. And then gagawin mo yung J, so 5. Tapos from J, gagawin mo yung L, that's 5 plus 15. So tapos ka na in 20 days. Pero hindi pa tapos yung project. Kasi matatapos yung project after 21 days pa. Okay? So, ganun yung idea ng PERT. Ganun yung idea ng critical path. So, ang tawag natin sa path na yan, critical. Now, why is it called critical? In project management, critical yan kasi once na ma-delay yung any of the edges connected to that path or lying to that path, madidelay yung buong project. Bakit? Kasi haba yung path na yan. Pero dun sa iba, pwedeng ma-delay ng konti. For example, yung E requires 9, sabi natin day, 9 days to complete from A to E. Tama? Pero, pagka gagawin mo na yung B, A to B, plus B to E, that's just 7. So, ibig sabihin, meron ka pang slack na 2 days. Di ba? Kasi tapos mo na yung 7 days eh. Ibig sabihin, halimbawa ito, pwede pa itong umabot hanggang 5. Okay lang. Hindi pa rin madidelay yung project. Right? O kaya pwedeng umabot to ng 4. Pwedeng umabot to ng 4, tapos ito 5. So, ibig sabihin, pwedeng ma-delay yung part na yun ng project. Right? Kasi bakit? 9 pa rin yung magiging total papunta sa E. Eh. Kasi wala tayong magagawa from A to E, 9. Eh. So, ibig sabihin, on other edges, meron ka tinatawag na slack. Ibig sabihin, pwedeng hindi mo muna matapos agad, pwedeng ma-delay ng konti. Kasi wala siya sa critical path. Pero anything on the critical path, kaya siya tawag na critical, hindi pwedeng ma-delay. Kung gusto mong makip yung schedule. Kasi pag na-delay yung A to E na yan, hahaba yung schedule ng A to E. Okay? Now, ang ginagawa in project management, pag kami na-delay na part at nasa critical siya, magre-re-ano ka ngayon? Magre-re-graph ka ulit. Magre-recompute ka. Bakit? Kasi baka yung critical path, dahil dependent yung na-delay na yon, halimbawa ito, kung na-delay ito, eh ito na-dependent yung D. Pag na-delay ito, madidelay yung D. So baka nababago na yung critical path. Or, the other way around, gagawa ka ng adjustment. Pwedeng, because this took shorter days, yung mga trabahador mo na nasa 3 and 4, pwede mong ilipat para tapusin yung A to E. Tama? Pwede mong ilipat kasi yung may araw siya na magiging bakante. Eh. So, pwede mong gawin, after niya yung A to B, B to E, ilipat mo yung trabahador dun sa A to E. Yan. So, pwede mong mapaigsi ngayon yung oras ng A to E, i-si critical path mo. Or, since alam mo yung mga critical path, magdadagdag ka ng manpower dun sa critical path. For example, matagal gayon yung A to E. Dagdagan mo ng manpower dun. If you have a spare. Or, i-decide mo kung mas matipid ba na dagdagan yung manpower dun kaysa dun sa time na matagal mong hinihintay. Okay? So, yun yung power ng PERT, ng project management. So, you can now use these informations to decide or to optimize your project or to properly manage your project. Yan. Very used itong critical path problem sa mga project management. So, now we are going to use PERT in project management in order to determine the critical path of this project with schedule given below. Now, let's say that we have a project with job A to H with the following description, the predecessor, and the normal time in minutes to complete that particular project. So, A is the start or the initial preparation, and that requires 10 minutes. So, maybe in a certain project, this is setting up the area, o kaya, usually, halimbawa sa store, opening the store. So, anything that needs prepping up to do before you can actually start the project. So that you just have an idea. Now, job B is get the dry materials. So, of course, job B is dependent on A. Diba? You need to prepare your setup first before you can start the project. Job C is get the wet materials. And it's also dependent on A. So, job B requires 40 minutes while job C requires 20 minutes. Job D is construct X. So, whatever X is. So, for example, you're constructing a part of a certain toy. Parang yan. Construct X. So, of course, X depends on B and C. To get the dry materials ready and the wet materials ready first. E is construct part Y. So, that's also dependent on B and C. So, job D requires 50 minutes and job E requires 10 minutes to complete. Job F is polish Y. Job G is to assemble X and Y. So, of course, for you to polish Y, kailangan nagawa mo na yung Y. So, F is dependent on E, and that requires 20 minutes. And then to assemble X and Y, that requires to finish constructing X and constructing Y first. So, that's dependent on D and E. F rather, kasi kailangan i-polish pa pala yung Y, di ba? So, D and F, and that took 40 minutes. And H is to finish. So, example of finishing activity are packaging, di ba? Babalutin mo na yung product mo. Or, I'm imagining if it's ordering a coffee, ilalagay mo na siya sa cup or something. So, it requires 10 minutes. Yan. So, this could represent a certain project. Yan. So first thing we need to do is to put the project in graph so that we know the dependencies of the activities. Let me rewrite the informations again simply. So we have A, B, C, D, E, F, G, and H just to check, right? And then the predecessors are B is dependent on A, C as well. D is dependent on B and C. E is dependent on B and C. F is dependent on E. G is D, F, right? Okay. H is G. I'm just double checking. So the times are 10, 40, 20, 50, 10, 20, 10, 40, 20. 10, 40, 20, 50, 10, 20, 40, 10. Okay. So, to have a better picture, so let's draw vertex A here, right? So, the activities that are dependent on A are B and C. So, there should be an arrow from A to B. So, let's say, let's put B here. And then, let's put C here. So there's no dependencies on B and C. So walang arrow from B to C or C to B respectively. And then I need to put job D, which is dependent on B and C. So let's say let's put job D here. So there should be an arrow from B to D and from C to D, since D is both dependent on B and C. There's a job E, both dependent on E and C again, right? All right. D is not dependent on E, so no arrow there. But F is dependent on E. So let me put F here. Pwede mo ilagay yung F sa kahit saan. It's up to you kung ano lalabas dun sa final na itsura ng graph ninyo. Pero of course, alam naman natin na isomorphic lang naman kahit saan mo ipwesto yan. Basta tama yung arrow. So E and then F. D and F no relation. Meron. Kailangan matapos silang dalawa bago magawa yung G. So let me put G here. May semblance of dependencies. And then once you finish G, you can start H. And then you're done. So this is the starting job. And this is the finish job. So once you've done A to H, then you're done. The job is done. All right. So what we want to do in project management is we want to determine the schedule of these activities. So here's how we gonna do it. Maglalagay ako ng mga box. Nalalagyan ko ng mga time. Depende dun sa mga informations na nasa table. Para mas makita natin yung flow ng activities. So in project management, ganito yung ginagawa nila. Okay? So imagine na parang ito yung schedule. Okay? Tapos, para lang medyo madaling matandaan, lalagay mo dito yung activity, yung job name, let's say A. Sa baba niya yung time na kailangan mo. Yan. Sa left niya, early start. Ibig sabihin, pag in-start mo siya, the earliest possible time. So, ano yung time na yon? Pag in-start mo siya the earliest possible time, mafi-finish siya ng earliest possible finish. So, early finish. Pero sometimes, there are activities that you can start late. So, lalagyan natin late start. Tapos, pag ginawa mo yun, ano na yung latest possible finish na pwede mong gawin? So, late finish. Okay? So, ES is early start. So, earliest possible time na pwede mo siyang start. Yung activity A. EF is earliest possible finish. So, that depends on T. LS is the late start. Ano yung latest na pwede mo siyang start? LF is the latest na pwede mo siyang ma-finish. Yan. Okay. So, lahat ng vertices, lalagyan ko niyan. So, let me copy that. So, let's say mag-start yung A dito. Tapos, ay wait, kailangan wala palang laman. Sorry. So let me just draw a blank table. Yan, lakayan natin para kitang-kita. Okay. So I'll do this for all the vertices. So dito yung para sa ito yung para sa A, ito yung para sa B, right? Ayan, B. D, D, and then C here, C, and then E, and then F. Medyo hinapos tayo ng space. Pusog natin. Okay, tapos G. So there's a G here. And then finally H. So there's an H here. So let's just rewrite the arrow. So that we can keep track of the dependencies. And then this is dependent both here. Yan. Very important yung arrow para sa dependencies. Okay. So the time required to finish A is 10. The time required to finish B is 40. To finish C, you need 20. To finish D, you need 50. To finish, what else? To finish E, 20. No, 10. Just 10. Tapos to finish F, 20. To finish G, 40. Medyo gandaan nyo na lang yung box para madali kayo makapagsulat. To finish H, 10. Medyo pangit yung pagka-drawing ko sa box. Okay, so dalawa yung gagawin nating pass. We need a forward pass. So, forward pass pa rin yan. So, para hindi tayo malito, pinalitan ko yung kulay. Now, the earliest possible start ng A is 0. Kasi yun yung starting eh. So, doon mag-start yung time. Okay. So, para matapos mo yung A, kailangan mo ng 10. So, lalagay mo siya sa early finish. 10. So, lahat ng dependent kay A, mag-i-start lang pag natapos na yung 10. So, yung ibig sabihin, ang earliest possible start ni B ay 10. Ganon din si C. 10 din. So, lalagay mo lang doon sa box ng early start yung early finish ni A. Kasi doon siya dependent sa A. Dependent si B sa A, dependent si C sa A. So, makakapag-start lang the earliest si B pag natapos na si A. Makakapag-start lang the earliest si C pag natapos na si A. So, yun yung ibig sabihin ng early start tsaka early finish. Now, pag nag-start na si B ng 10, matatapos siya after 40. So, 10 plus 40, 50. So, ang early finish ni B, 50. Okay? Now, si C naman, ang early finish niya, 20. Ay, sorry. Plus 20. So, 30. Tama? Kasi ang C ay 20. Okay. Now, ano ngayon yung magiging early start ni D? Si D may dalawang arrow na nakakabit sa kanya. Kailangan matapos si C saka si B bago mag-start si D. Si C matatapos ng 30, si B matatapos ng 50. So, hindi makakapag-start si D hanggat hindi natatapos si B. Kasi siya yung mas matagal matapos eh. Kahit tapos na si C, kung hindi pa tapos si B, hindi magsisimula si D. So, that means ang early finish ni D ay yung 50, hindi yung 30. Okay? Yung mas malaki. So, early finish ni D, 50. Now, si E, dependent din siya kay B tsaka kay C. May arrow from B to C. Ibig sabihin, to be technical, dapat yung arrow na to dito yan. Para hindi kayo malito. Kailangan ma-finish muna yun. Okay, so anyway. So, si E, dependent kay B, na matatapos pa ng 50, tsaka kay C, na matatapos ng 30. So, sino mas matagal? Si B. So, yun din yung early start ni E. Yan. So, anong early finish nila? Si D, matatapos siya after 50 minutes. Tama ba? D, 50. So, 50 plus 50, 100. So, matatapos si B at time 100. Si E, matatapos siya at time 60. Kasi 10 minutes lang yung E. Right? Okay. Now, ang early start ni F, dependent lang naman siya kay E. So, pwede na mag-start si F ng 60. And then, ang F ay process taking 20. So, 60 plus 20, 80. So, tapos si F at time 80. Si D tapos at time 100. Si G dependent both on D and F. So, kailan lang mag-start si G? Pag natapos na si D, kasi siya yung mas matagal. So, early finish niya ay 100. So, ang idea, kukunin mo lang yung mas matagal doon sa dependencies niya. So, ito, isa lang ang dependent. So, kung ano yung value, carry over. Ito, isa lang ang dependent. Kung ano yung value, carry over. Pero pag may maraming multiple coming in, kukunin mo yung greater value. So, greater value ng multiple early finish ng mga dependencies niya. Yan. So, ang early finish dito, 50-30, mas malaking 50. So, yun yung magiging early start niya. Sa G, ang early finish ay si F ng 80, si D ng 100. Sino mas matagal? Si D. So, si D yung makikarry over. Lagi yung greater early finish. Yung bigger value. Okay. After ng G, matatapos siya ng 40. So, si G matatapos ng 140. So, 140 pa makakapag-start si H. So, after 10, 150. So, after 150 minutes, tapos yung project. Okay? After 150 minutes, tapos yung project. Now, kailangan natin, para mas madali nating makita kung ano yung critical path, gagawa tayo ng backward pass. Para rin makita natin yung early finish tsaka late finish naman. Late start tsaka late finish rather. So, late start, late finish, let's do the backward pass. So, ito namang backward pass, titingnan mo naman, what if late ka na nag-start? Ibig sabihin, ano na yung pinaka-late na pwede mong i-finish yung project? Of course, kung ano yung value sa 150, gusto mo, yun din yung latest. Kasi ayaw mong ma-delay. Okay? Now, so, 50 minus, 150 minus 10, 140. So, ibig sabihin, para hindi ma-delay yung project, the latest na mag-i-start yung D, dapat 140. Para hindi ma-delay. Okay. So, kung ano yung late finish, yun yung ipapasa mo sa late, kung ano yung late start, yun yung ipapasa mo sa late finish. So, pabalik naman to, pabalik. So, ang panggagalingan lang ng man ni D pabalik, ni letter to, H pabalik, G lang. So, 140 to. So, kung nag-start ka kung gusto mong matapos ng 140, dapat mag-start ka ng 100. Yan. So, at time 100, natapos na yung, nag-start yung G. So, si F, pwede siyang mag-late finish hanggang 100. Hanggang 100, pwede siyang mag-late finish. 100 minus yung time para tapusin si F ay 20. So, 80 yung pinaka-late start ni F. Ibig sabihin, kung minamanage mo yung time mo, pwedeng si F, start mo ng 80. Hindi mo kailangan start ng 60. Latest possible start mo 80. Para matapos ka ng 100. Kailangan mo matapos ng 100 kasi yung D matatapos din ng 100. Kumbaga, parang pinagsabay mo yung ending. Sabay sila mag-start si G. Okay? Now, ang latest finish ni E, since isa lang naman yung pinanggagalingan niya, yung F lang, 80. So, carry over lang yung 80 dito. Okay? Now, 80 minus 10, 70. So, latest start ni E, 70. Punta tayo kay D. Si D, 100 yung late finish niya. Doon lang naman siya manggagaling kay G. Pabalik pabalik. So, 100 minus 50, 50. Okay, now, dalawa yung panggagalingan ng B. Manggagaling siya kay D, manggagaling siya kay E. Or yun yung pupuntahan. From B, papunta siya ng D, papunta siya ng E. So, ibig sabihin, kung ito ay matatapos na ng 80, ito matatapos ng 50, ang pinaka-late finish nung, wait, nasa na ba yung direction natin? Ganun. Ang pinaka-late na finish na ni B, syempre, yung 50. Kasi hindi siya pwedeng matapos ng, wait, ano yung nasa baba? Nahihilo ako sa sulat ko. 70. 70. Hindi ako pwedeng matapos ng 70 kasi hindi makakapag-start ng 50 yung ito. So, ito okay lang matapos ng 70 yung E. Pero yung D, hindi. Kailangan mag-start siya ng 50. So, dito, 50 pa rin to. Yan. So, anong kinuha natin? Ang kinuha natin yung smaller. Okay? Kinuha natin yung smaller dun sa dalawa. Kumbaga, naka-arrow siya from D tsaka from E. So, 50 yung nasa baba, nasa taas, yung nasa baba, 70. So, ang kailangan kunin mong late finish, yung mas maliit. Okay? So, ganun din dito sa C. Late finish na nung nasa taas ay 50, late finish na nung nasa baba ay 70, kailangan kunin mo yung smaller value, 50. So, kanina sa forward pass, ang kinukuha mo, bigger value sa forward pass. Kung dalawa yung dependencies niya, ang kinukuha mo dito, bigger. Pero sa pabalik, ang kinukuha mo dito, smaller. Yan, tandaan nyo yun para di kayo malito. Pag forward pass, kinukuha mo bigger. Pag backward pass, kinukuha mo smaller. So, 50 minus, punta tayo sa C, 50 minus, ano nga ba yung sulat ko dito? Ang C ay 20. So, this is 30. 50 minus 4, 10. Okay. So, 10 and 30, okay. So, isang arrow lang yung A manggagaling kay B. So, 10. Dito manggagaling 30. So, ang kukunin mo lagi, smaller. So, this is 10. Again, pabalik yung pass pabalik. So, 10 minus 10, 0. Okay. So, ano interpretation nung nakuha nating graph? Ito yung interpretation niya. Para makuha mo yung critical path easily. Ang critical path is kung saan nagiging equal yung early finish sa late finish. So, kailan equal ang early finish sa late finish? Pag equal yon, ibig sabihin, critical yon. Kasi ibig sabihin, hindi pwedeng may ma-delay. So, dapat, equal lang yung early finish mo sa late finish. Ibig sabihin, pag hindi nag-equal yon, tatagal yung process na yun. Tama? Pagka yung late finish mo, pinahaba mo. So, ang mga critical path ay yung mga table kung saan equal yung early finish at late finish. Well, in our informations, ito yung equal yung dalawa. Ito, ito, tsaka this one. So, that means, yung path na yon critical. So, anong path yon? So, those are the path from A to B to D to G to H. So, A to B to G to H. So, this path are critical. Ibig sabihin, pag may dinelay ka sa path na yan, madidelay yung buong project. Hindi siya mapifinish at the minimum time na, so ano yung level ng H? 150. So, kung ano yung label, yun yung time required to finish that particular activity. So, the critical path are the activities consisting of A, B, G, H. Yeah. So, any activities not on the critical path has a slack. Ibig sabihin, pwede nating i-delay yung activity na yon. And it doesn't matter. It will not affect the schedule for as long as hindi ka lalagpas sa late finish. Yan. So, ano interpretation nito? For example, so, ang interpretation yan, kung gusto mong ma-keep on schedule, ang latest possible start mo na ay at time 30. Kasi at time 30, matatapos ka at time 50. Yun yung finish ng critical path eh. Time 50. Diba? Noon matatapos yung critical path. So, ibig sabihin nun, once natapos yung nasa critical path, kailangan ikaw na nasa C, tapos ka na rin dapat para hindi ma-delay. So, ang pinaka-late start mo na 30. So, hindi mo kailangan mag-start ng 10, matatapos ka ng 30. Pwede ka mag-start ng 30, matatapos ka pa rin on time. So, hindi mo naapektuhan yung schedule. Hindi mo dadagdagan. Pero pag yung late start mo, in-adjust mo, ginawa mong 40, ma-adjust to, magiging 60 to eh. O di mababago yung critical path mo. Okay? So, ang slack nito, 20 minutes. Slack. Ano ibig sabihin nun? Pwede ka ma-delay hanggang 10 lang pala, sorry. Hindi, tama, 20 minutes kasi 30 minus 10. So, pwede ka ma-delay ng 20 minutes. Slack yun. Or, the other way around. Pagkatapos mo, matatapos yan ng 30. So, pwedeng meron kang waiting time na 30 minutes to 50 minutes. So, waiting time mo na yun. Kasi hindi mag-i-start yung kasunod mong process eh. Kung dependent, ito 50 eh. So, ibig sabihin, from 30, pwedeng nag-iintay na lang. Well, in this case kasi, may kasunod siya na process. So, tignan natin dito sa part na to. Matatapos na ng 80. Ito, matatapos pa ng 100. So, yung gumagawa ng F, pwede na siya mag-intay from 80 to 100. So, may slack siya na 20. Ibig sabihin nun, pwede siya maghintay hanggang 100 bago niya simulan yung G. Yeah. So, as project manager, it's up to you how to delegate the task. So, pwede mong yung nag-iintay na yun, ilipat mo siya ng gagawin, tulungan yung nasa D. Yeah. Kaya syempre, dapat alam din niyang gawin yung D. So, it also matters in project management, yung allocations ng resources. So, ibig sabihin, yung mga nasa critical path, yung gumagawa dito, yan. Dapat as much as possible, available yung mga tao mo na expert gawin yung mga activity na yan. Kasi for example, yung nandito, hindi pala niya kayang gawin yung D, wala rin tayong magagawa. Isang advantage pa nito, for example, pwede mong i-schedule yung tao mo na papasok siya sa opisina or papasok siya sa isang project by the time na nandun na sa critical yung ginagawa. Pag gumawa ka ng time schedule. Right? So, it's up to the project manager kung paano i-schedule properly. So, either once you analyze the schedule, pwede mong paigsiin pa by one is you can augment personnel to do certain part of the activity. So, syempre, pag nagdagdag ka ng tao, mababawasan yung time. Pero syempre, dapat, titingnan mo rin kung yung na-save mo ba na time ay mas beneficial sa ginastos mo dun sa augmented personnel. Syempre kasi pag dinagdagan mo ng personnel, magdadagdag ka ng sweldo. So, kasama yun sa project management analysis. Yan, sa critical path analysis. Pwede rin naman na yung mga idle mo, since may slack ka, ilipat mo sila. Kasi may slack ka. So, those are the possible scenario that you can do na naging possible because of the critical path or PERT method. Again, that's from the critical path problem for project management. Okay? So again, ang maganda sa determining the critical path is you can always determine which path you want to focus on kasi siya yung nagbibigay sa'yo ng longest path. Which in turns give you the minimum number of time or days or minutes, kung ano man yung unit of time mo, to finish the entire project. So for any activity not in the critical path, you can have a slack. And any delay in this activity may or may not affect the end time itself. Well, it will not affect if you're within the slack. Ibig sabihin, kung hindi ka lalagpas dun sa slack mo, syempre, hindi maapektuhan yung schedule mo. Pero pag ang naapektuhan mo or ang na-delay, yung nasa critical path, automatic, madi-delay yung schedule mo. Yan. So this time, this is the Chinese Postman problem. Yan. Ito mga application na to, ito yung mga common applications na madaling maintindihan in graph theory. So, and I can see na most of your expositions are based on these applications. It will help you in exposition kung naaral nyo itong mga applications na to. So, ano naman ibig sabihin ng Chinese Postman problem? So, ang Chinese Postman problem is first introduced by a Chinese mathematician named Megu Guan. Yung iba, ang English name niya, Mei Q Kwan. So, baka yung iba yung na-search na pangalan ng mathematician. So, ang Chinese name niya, Mei Gu Guan. So, ang problem, meron daw postman that wishes to deliver his letters, covering the least possible total distance. So, distance dependent to. And returning to his starting point. So, ang mangyayari, he must traverse each road in his route at least once. Pero sometimes, dumarating sa point na kailangan mong ulitin yung certain route. Kasi there's no other way. May mga ganong graph na you cannot traverse it once unless it's a Eulerian graph, di ba? Siyempre, a Eulerian graph, you can traverse it once using a Eulerian circuit. If you still remember our topic, discussions on Eulerian graph. Pero once it's not a Eulerian graph, then you're forced na may uulitin kang road. So ang Chinese Postman problem, ang tanong, ano yung road na uulitin mo para minimum yung total distance na mako-cover mo. So you want to, as much as possible, avoid covering too many roads. Siyempre, technically speaking, so let's say this is our scenario. The towns are, or the corners of the streets are A, B, C up to F. Pwede mo namang punta ka sa B, balik ka sa A, tapos from A, punta ka sa F, di ba? From F, pwede kang bumalik sa A, or wag kang bumalik, punta ka sa C, sa D. So you can have different routes hanggang, syempre kailangan mong madaanan lahat di ba? Kailangan madaanan lahat ng street. So there are numerous possibility, pero syempre always may kailangan kang ulitin. Kasi kailangan bumalik sa post office. Okay? So ang gusto mo ay hanapin yung route na magbibigay sa iyo ng kung may uulitin ka man, least possible yung distance na mako-cover mo. Least possible. This is different from traveling salesman kasi ang traveling salesman, kailangan mo lang ma-reach yung city. Ito, kailangan mong daanan lahat ng road. Kasi baka may sulat sa mga road na yun. So, we're assuming na kailangan mong daanan lahat ng road kasi magdi-deliver ka doon sa lahat ng road na yun. Unlike sa traveling salesman problem, kailangan mo lang puntahan yung specific vertex pero hindi mo kailangan bisitahin lahat ng edges. Okay. So, this is simply a Eulerian problem. A problem of finding a Eulerian path. Bakit? So, if we imagine that A to F refer to the intersections and connected by road marked with its length, diba? So, ang post office is A kasi ikot ka sa lahat ng road. So, ibig sabihin, from the given graph itself, ang hinahanap mo, Eulerian path. Ano ibig sabihin ulit ng Eulerian? Eulerian, pag nadaanan mo lahat ng edge, one and only once. Plus, pabalik. Kung na-end ka sa hindi Eulerian na graph, ibig sabihin, hindi mo kayang bumalik once and only once. So, kailangan mo ng pabalik na path, pero automatic may magre-repeat na edges. So, in a way, it's like a problem of finding a Eulerian path. Yan. Sa problem natin, it's easy to determine yung given natin ay hindi Eulerian. Again, ano ang criteria para masabi mong Eulerian? Pagka puro even ang edges, ang indices, ang vertices, ang degree ng vertices, Eulerian. Ibig sabihin, pag even yung graph, di ba? For example, ito, 2 ang edges. So, ang degree 2, degree 3, degree 4, degree 2, degree 3, degree 4. So, hindi siya Eulerian kasi meron kang degree 3 tsaka degree 3. Tama? So, this is not a Eulerian graph. This is actually semi-Eulerian. Diba? Ang semi-Eulerian, meron kang starting point, malalakaran mo lahat ng edges pero hindi ka makakabalik. For example, if I start at B, yan, pwede akong umikot, ikot, ikot. Ayan, nadaanan ko lahat yung path once and only once. Right? Kung nakalimutan niyo na, remember again our lesson in Eulerian graph. So you just have to find 2 odd vertices. Exactly 2 odd vertices para masabi mo na semi-Eulerian siya. This is non-Eulerian kasi add yung ibang vertices. Pero pag exactly 2 lang, semi-Eulerian. Pag more than 2 or isa, non-Eulerian yan. Okay. So anyway, so this is a semi-Eulerian graph. So that means you can go from B to E. Pwede kang pumunta from B to E using a semi-Eulerian path pero hindi ka na makakabalik kay B. So ibig sabihin, kung gusto mo makabalik kay B, kailangan mo maghanap ng shortest path from E to B. Pero we're already done with finding the shortest path. Gagamit ka lang ng Dijkstra algorithm. Diba? Gagamitin mo lang yung Dijkstra. Mahanap mo na yung shortest path. So, upon analyzing what's the shortest path between B to E. So, since madali lang naman yung graph, pwede mong isa-isahin. Halimbawa, pwede kang dumaan dito, or dumaan dito, or dito. Diba? Yan yung mga possible route. Yan. Or ito. Tapos kunin mo lang yung mga may least value. Or you can perform Dijkstra's algorithm. Pwede. So, paano ba i-perform yung Dijkstra's algorithm dyan? So, if I want to start at E, kasi pabalik na ako. So, let's perform the Dijkstra's algorithm. So, ang label ng starting point ay 0, coming from E. So, from here, I can go to F6 or D9 or C10. Since the smallest is 6, I'm fixing 6 from F, from E. Fix na yon. Fix na rin to. Tama? Fix yan. From F, pwede akong pumunta kay A, so that's 6 plus 4, 10. Pwede akong pumunta kay B, so that's 6 plus 8, 14. Pwede akong pumunta kay C, that's 6 plus 14, 20. Pero mas maliit yung 10, so I'm keeping 10. Okay. From here, the smallest is 9. So, this is fixed coming from E. And then, I can go to C. 9 plus 5, 14. 14. That's still bigger than C, so I'm fixing 10. I'm keeping 10. Yan. Okay. Ano yung susunod na smallest label na unvisited? Yung 10. So, I can start from A or from C. It doesn't matter. Okay lang kahit saan mag-start. So, for example, I start with A. So, since this is smaller, I'm fixing this. From A, I can go to B. So, that's 10 plus 3, 13. So, that's smaller. So, I'm relabeling B as 13. That's coming from A. This is coming from E. From F, rather. Now, the next smaller label is 10. So, 10. From here, I can go to B, 10 plus 5, 15. But that's bigger than 13, so I'm keeping 13. So that means this should be 13A, and this is fixed. So, from E, the smallest path going to B has length 13. Yun yung sinasabi. So, pwede na akong pumunta, aling path yun? Backtrace. 13 from A, 10 from F, 6 from E. So that means yung pala yung shorter path. Pabalik. Nadaan ka ng E, from E go to F, then to A, and then to B. Okay? So pagsamahin mo na yung concept ng Eulerian circuit or semi-Eulerian path tsaka yung shortest path. So anong nangyari? So 'di ba kanina naghanap muna tayo ng semi-Eulerian trail. So for example, kanina kumuha ako ng trail from B, paikot. Yan. So that's a trail from B to E. So nakuha ko na lahat ng edges. So ano magiging total length niyan? Simply the sum of all the weight of the edges. Tama? I-add mo lang naman kasi dinaanan mo pa lang only once eh. So i-add mo lang. So 3 plus 4 plus 8 plus 5 plus 14 plus 6 plus 10 plus 5 plus 9. So the graph has a total weight of 63. One method, pag komplikado na yung graph, pwede nyo ulit balikan yung Flores method natin. Yung Flores method, yung naghahanap ka ng Eulerian path. So the next is to find the shortest path from E back to F using Dijkstra. So nakita na natin na ang shortest path is this one. Right? So ang shortest path natin is E, F, A, and then B. So, ang length niyan, 6 plus 4 plus 3, 13. So, that means, our Postman trail will be, you add the two trails para sa Postman trail. So, again, that's ito. Yan yung semi-Eulerian. Tapos, idadagdag natin yung dalawa pang path, yung shortest path. So, magkakaroon tayo ng Eulerian trail. This time, it's Eulerian na, di ba? Kasi pag tiningnan mo yung nabuo nating graph, nagiging 4 na yung edge niya eh. Kasi nadagdag yung isang trail na pabalik. Ito, nadagdag yung isang trail na pabalik. Ito, nadagdag. So, naging 4 na. So, ito, 1, 2, 3, 4 na yung vertices, 4 na yung vertices. Ito, nagdagdagan ng dalawa, 6. Ito, naging 4. Ito, naging 4. Ito, 2 pa din. So, that means, puro even na. So, Eulerian na siya. And actually, yung nakuha nating trace, that's the Eulerian trail already. Tama? Yung tinrail, yung kinuha nating trail. Which trail is that? Yung semi-Eulerian trail, starting from this one, yan. Yun yung sinundan natin na semi-Eulerian trail, and added the shortest path from E to B. These three edges. So that's a Eulerian circuit. Okay. So, paano mo mahanap yung Postman trail? Eh, ang Postman, kailangan mag-start ka sa A. Since may circuit na tayo, ang gagawin mo lang naman, start mo yung circuit mula dun sa A, dun sa desired starting position. So, kung nasan man yung Postman, post office dyan, kung saan man niya gusto mag-start, yun yung gagawin mong start ng trail. Following the circuit itself. O, di alam mo naman na from A, pwede kang pumunta sa B. Pag finalo mo yung circuit, A to B. And then from B, sabi nung circuit, punta ka sa A ulit. And then from A, punta ka sa F. You are now following the circuit. And then from F, balik ka sa B. And then from B, punta ka sa C. And then from C, punta ka sa F. From F, punta ka sa E. Then punta ka sa C. Then punta ka sa D. Then E. Then F. Then back to A. Kumbaga, dun sa circuit na nabuo natin, mag-start ka lang sa A. Following that same circuit, you can go back to A. And that's the shortest possible route for the Postman. So that's a combination of the Eulerian graph, the semi-Eulerian path rather, plus the additional shortest path. The semi-Eulerian trail together with this path is the Eulerian circuit of length. So, ano yung length nung Eulerian trail natin, nung semi-Eulerian, 63. Yung idinagdag nating path, 13. So, that's simply 63 plus 13 or 76. Okay? So, why are we sure that this is the shortest? Kasi shortest route yung binigay natin yung E to B. So, that's also the shortest trail for the postman. Ang difference nga lang, may mga edges na inulit mo. Kasi, no choice ka. Kung Eulurian yon, hindi mo kailangan mag-ulit ng path kasi makakakuha ka ng Eulurian trail. Pero since hindi siya Eulurian, ginawa natin siyang Eulurian. So, yun yung idea. Nag-add tayo ng path. So, ito yung dinagdag natin. Ito, tsaka ito. Yung tatlong path. Take note that the postman can add any path. Pwedeng dito siya dadagdag or dito. Pero by the Dijkstra's algorithm, we know that what we choose is the shortest path. So the postman trail is the shortest postman trail. So this will summarize the algorithm na discuss natin for the postman. This is called the route inspection algorithm. So ano ginagawa ng route inspection algorithm? First, ina-add natin yung total weight ng graph so that we have an idea kung gaano kahaba yung buong trail. Then, we write down the degrees of each vertices to identify kung Eulurian ba siya or not. So, pag may nakita tayong add vertices, ibig sabihin, hindi siya Eulurian. So, that will initiate the process. So, pag meron ka ng vertices na add, ang gagawin mo lang, kukunin mo yung shortest distance from that two add vertices. Now, the problem is, paano kung hindi lang dalawa yung add vertices? Paano kung may iba pang add vertices? So, ang gagawin mo lang, konting probability, kukunin mo yung possible combination. Number 4, choose the pairs of add vertices so that the sum of the weights of the pairs from all the pairs that we have is minimum. So, ang mangyayari, since meron kang more than 2 add vertices, pagpapares-paresin mo yon, and then you will get the shortest possible distance from those pair of vertices. So, for example, just to illustrate, this is a road, tapos yung intersection yung vertices natin, okay? And then the road connecting them will be our edges. So here, the degree is 2, the degree is 3, the degree is 3, the degree is 3, the degree is 2, 3 rather, and then 2. Don't worry, laging even number of add vertices ang lalabas. So either 2, 4, 6, 8. So laging pwede kang magpares-pares. So ang gagawin mo, maglalagay ka ng pairing ng vertices. For example, ipe-pair mo yung vertex na to sa vertex na to. Pag silang dalawa yung pinair mo, automatic, ito na yung mape-pair. And then you get the shortest possible distance from that pair of vertices. Ano yung shortest possible route mula dito papunta doon? Syempre, going to the roads, along the roads. Tsaka mula rito papunta ron. So that's one scenario. And then you do that for all the possible scenario ng pairing of vertices. Siyempre, pwede din naman na ang pinair mo ay hindi yon. Pwede mo naman itong dalawa na itong ipe-pair. So this is pair 1. Tapos ito, pair 2. So pwedeng itong dalawa na to, tsaka itong dalawa na to. Or pwedeng itong dalawa na to, tsaka itong dalawa na to. So those are your possible scenarios. So, ang sabi nung step, ang gagawin mo, choose a pair of vertices and then find the shortest distance from that pair of vertices. Then, add mo lahat. For each scenario, add mo lahat ng total distance. So, which scenario will give you the least sum? Yun yung magiging scenario para doon sa postman trail mo. Okay? Kanina madali lang kasi isa lang yung pares ng add vertices B lang at saka E. So, isang shortest possible distance lang kailangan mo. Pero pag marami na, kukunin mo yung possible scenario para makuha mo yung least value. Okay? So, nadadagdagan lang yung process depende sa possible pairing na gagawin natin. So, finally, pag meron ka ng nakuhang least possible sum from all the scenarios that you have, add those vertices. Idadagdag mo, iduduplicate mo yung path na yon para maging Eulerian na yung trail. So let's see in our example. So for example, this is our graph. So we need to convert this into a graph. So madali lang namang i-convert sa graph. For example, this is the post office. B, C, D, E, F, G. So connected ang A to B, ang B to C, ang A to C, ang C to D, ang D to E, ang E to F, ang F to G, ang D at G, at saka ang D at A. So that's our graph. And then the weight of the graph are as follow: 42, 45, 35, 60, 70, 20, 40, 80, 50. Okay? So now from your graph, you can easily identify whether it's Euler or not by identifying the degrees of the vertices. So this is degree 2, this is degree 3, A has degree 3, D has degree 3, G has degree 3. E has degree 2, F has degree 2. So we list now all the vertices with odd degrees. So ano yung mga vertices with odd degrees? A, C, D, G. So you construct the possible pairing of vertices. So ano na lang to, simple probability, counting. Pwedeng si A naka-pair kay C. Pwedeng A to C. Now, pag si A, pinair mo kay C, automatic, si D, mape-pair kay G. Yan. Pwedeng si A, i-pair mo kay D. Pero pag si A na kay D, si C, mape-pair kay G. Matik yun. Pwedeng si A, i-pair mo kay G. So, that will mean si C kay D mape-pair. And that are all the possibilities. These are all the possibilities. Wala nang iba. For example, sir, I want to pair C and D. Meron na yun. Ito na, C and D. Nandun na yung pairing na CD. Sir, gusto ko i-pair yung C at G. Meron na yun, CG. O, tingnan natin. Meron tayong 4 possible vertex combination taking 2 at a time. Tama? So, anong sagot niyan? So, that's 4 factorial over 2 factorial times 4 minus 2, 2 factorial. Cancel yung 4, matitira 3 factorial, cancel yung 2. So, ang natira, 6. Tama? So, 6 possible pairing lang. 1, 2, 3, 4, 5, 6. So, ayan na lahat yan. Okay, so we're already sure that we can have 3 possibilities. 6 possible sharing of pairings of vertices consists in 3 different possibilities. Yan. Kasi yung pairing na to magkasama sa isang possibility. Okay. So we're done with the pairings. Next, we want to determine the possibility that will give the least added weight or the least added path. Okay. So ang gagawin mo, hahanapin mo yung shortest path from A to C. So, kung simple lang yung graph, madaling makita. Pero kung komplikado yung graph, pwede mong gamitin ng Dijkstra. So, laging Dijkstra pag shortest path. For example, ang A to C, ito yung A to C. It's very obvious, the shortest path is 35. Alam ka naman pumunta ka pa ng B bago C. Mas mahaba yon. 42 plus 45. So, it's easy to see na 35 yung A to C. So, that's A going to C. That gives us 35. How about D and G? D and G is 20. Mas mahaba pag umikot pa ako dito or dito. So that gives me D to G of length 20. Again, if the graph is more complicated, hindi madaling makita yon. So gagamit ka ng Dijkstra. Pero in our illustration, madali namang makita. A to D. So, walang direct path from A to D. So, pwedeng papunta ka sa C which gives you 95, or dadaan ka sa G, which gives us 70 plus 20, 90. So, mas maigsi yun. So, ibig sabihin, that's A to G to D. Yung iba pang possible path, mas mahaba. Kaya hindi natin i-consider. So, yun lang yung possible na logical isipin. So, that's A to G to D. That gives us 90. C to G is either dito, that's 80, or dito, 105. Pwedeng through D or through A. Pero mas maigsi kung through D. That's 80. So, C, pupunta muna kay D, and then pupunta kay G. That gives us 80. Right? Okay. A to G. Ito si A, ito si G. 70. Yun ang pinakamaigsi. A, diretso kay G. 70. C to D. C, diretso kay D. 60. Again, kung mahirap yung graph, kung hindi simple, gagamit ng Dijkstra. So these are all the path that you need to include. Pag ang pinili mo possibility 1, you need to add 55 more. Pag pinili mo possibility 2, you need to add 170 more. Pag pinili mo possibility 3, you need to add 130 more. So the most logical choice is 55, since this is the smallest. So we always choose the smallest combination. So we get possibility 1. So that means what we need to do is to add the edge A to C and the edge D to G. Okay? Yun yung i-add mo. So going back to our illustration, idadagdag daw natin yung edge na A to C. So magdadagdag tayo ng edge dito. Kumbaga magiging dalawa yung road. Tsaka dito. A to D and D to G. Of course, same weight yun. 35, 20. So now, you now have a Eulerian graph. Ang degree 2, ito naging 4, ito naging 4, ito 2 pa din, ito 2 pa din, ito naging 4, ito naging 4. So Eulerian na siya. So the last thing to do is to find a Eulerian circuit. Right? So paano ulit maghanap ng Eulerian circuit? You start with any vertices and then follow the Floor's method. So, kung i-follow natin Floor's method, or kung madali lang namang imaginein, for example, dito tayo mag-start. Let's find the path. So, B to C, that's 1. C to D, D to E, E to F, F to G, and then daanan ko na yung road na to. Tapos, diretso ako sa A. And then from A, daanan ko ulit yung dalawang additional na to. And then, balik ako kay B. So, together with the added path, nadaanan natin yung lahat ng path exactly once. Except dun sa dinoble natin yung road. Pero that's the minimum, the least additional weight that we can have. Right? So, ano yung trail? Magsimula ka sa A. Circuit yung ginawa ko eh. So, okay lang kahit saan ka mag-start pag circuit. Pero yung trail galing sa post office. Andito yung post office. So, A, pumunta kay B. So, sundan lang natin yung circuit. Pumunta kay C, pumunta kay D, pumunta kay E, pumunta kay F, pumunta kay G, and then si G, nag-back and forth sa D. So, D to G. And then, kay G na ako, punta ko kay A. And then, pag kay A, back and forth ulit kay C. Kumbaga, yung pinakamaliliit na portion ng road yung dinodoble mo. So that you're sure that you have the least possible route. So this is C. Then balik ako kay A. So ano yung total distance? So kanina, kinumpute natin yung weight. Ang total weight na na-compute natin ay, di pa pala natin na-compute yung weight, no? Okay, so compute natin yung weight. So that's 42 plus 45 plus 35 plus 60 plus 70 Asan na tayo? Plus 20, plus 90, plus 80, plus 50. So, let's double check kung tama yung pagkaka-add ko. 492. Tama ba? 492. Alright. So, plus the additional 55, so the total weight will be 492 plus 55. So that gives us 547 unit of measurement. Kung ano man yung unit of measurement na ginagamit. Okay? So 547. Again, we are sure kasi using Dijkstra, these are the least possible combination or least possible added weight na pwede nating makuha using this. So, ang crucial part dito ay the pairing. Kailangan makuha mo lahat ng possible pairing ng add vertices. Yan yung crucial part. And then you just get which combination will give the smallest added weight. Ito added weight kasi ito eh. Kasi siya yung kailangan mong doblehin ng daan para makabuo ka ng Eulerian trail. So the idea in the Postman, Chinese Postman problem is to create or to transform your graph into a Eulerian graph by adding the edges with the least possible weight. So, pwede rin na kung kita mo na yung graph, idagdag mo yung edges na maliliit lang yung weight hanggang maging Eulerian. So, may dodobling ka lang ng mga edge. So, for example, meron kang graph. So, ang gagawin mo lang, mag-a-add ka ng mga, hindi pala to non-Eulerian. So, pag may nakita kang add na what you call this, add na vertex, ang gagawin mo lang, add to add, magdadagdag ka ng path papunta dun sa add vertex to add vertex, such that yung dadaanan mo, papunta dun, minimum yung weight. So, yun yung idea. Pag nagdagdag ka kasi ng isa pang edge dyan, magiging dalawa na to, magiging apat na to. So, even na ulit siya. Basta may even ka, meron kang Eulerian graph. Basta lahat ng edges mo, lahat ng vertices mo ay even ang degrees, automatic Eulerian graph. Dahil Eulerian graph, automatic may Eulerian trail. So, ang matitira na lang na process, mag-create ka or hanapin mo yung Eulerian trail na kailangan mo. Okay? So, that's the Postman, the Chinese Postman problem. Now, usually, ang Chinese Postman problem ay related into delivery system. Basta it has something to do with delivery system na kailangan daanan mo lahat ng edges. So, Chinese Postman problem yan. Again, this is different from traveling salesman kasi ang traveling salesman naman, ang kailangan mo lang daanan lahat ng vertex without considering any required edges.